that. It must be heating or something. Go ahead, control.
Okay. Any one of the two following breakers can be closed, and he'll have his lights on his diski, the caution lights on his diski.
Well, do we want to do that?
Well, that explains why he didn't get the caution a while ago.
Are you proposing to close these breakers?
Aquarius Houston, we see
I'm going to
SN
get a current
O2
drawn
tank
on
number
first.
2 building up
Okay.
again, so
Understand.
we'd like to use something out of it, so turn on SN O2 tank number 2 and turn off descent O2.
Roger, open up ascent O2 tank number 2 and turn off descent.
Tell me your flight.
Go, Frank.
I now want to hear about CO2 removal.
Okay, Frank. What we need to do is...
Let me be sure that everyone's hearing this. I want you to hear Joe and Jack.
Okay.
Go ahead.
What we want to do is take the commander's suit hose and cap the return hose. That's the red one, suit loop inlet. Okay. Cap the return hose portion.
Stand by. Let me write it down. Take the commander's hose and cap the red one.
Right, the return hose.
All right.
Okay, and then take this hose and stick it up in the tunnel as far as you can get it.
All right.
And this should circulate some O2 in there.
Will it circulate the entire output of the suit loop to the CM first? Is that what it does?
Just half of it.
Half of it. Okay. Okay, the half to that suit hose.
Yeah.
Okay. Well, that sounds like a very passive thing.
Yeah.
And reasonable. Anybody got any objection to that?
And span right now is says this is an acceptable mode. They're working on what the CO2 rise rate is.
Tunnel. Stick it up as far as you can in the tunnel. Go ahead, Merlin. I didn't hear you last.
I was saying the span people are working on the CO2 rise rate, millimeters of mercury.
Fine.
But what they're saying that the rise rate should be acceptable in that configuration.
Not only that, that's the best we can do.
Yeah, unless
we pump both.
the only other thing we could do is be able to take one of the CMP hoses and cut it or something and tape it to the limb hose and lengthen it.
Well, okay, assuming they'll be satisfied with this, Jack, why don't we recommend that? That seems like a very simple precaution to take here.
In Aquarius Houston, we're starting to think about CO2 buildup up in the command module there, so we've got a recommendation. And what we're recommending is that you take the commander's hoses in the limb and put a cap over the red return hose.
Remain pressurized before it bleeds down?
And figure out a way to fasten those hoses so as they blow up into the CSM by extending them up through the tunnel as far as possible. And we'll get some flow out the blue side, circulate it up around in the command module, and keep the CO2 level down.
I'm sorry, Jack, I didn't copy.
Roger,
Okay,
full
bladder.
Full
pressurization
on the comm is
Probably
connected securely to the
Okay, thank you.
hose, so we've got to get the comm cable off somehow to get that. We still have comm down here in the limb and have the hose up there.
Can we use a different hose?
Well, we have to use one of them flat. See if we can pull the comm cable off.
Can they pull it off?
Stand by.
Just let one guy do the talking tonight.
Yeah, we're checking fine.
That's... Now, the only question is, you want him to tear it off or just let one guy talk? Rather than tearing it apart, why don't we just let one guy do the talking?
I think that's the best one.
Jack? Rather than them trying to really do anything in that, why don't we just let one guy do the talking? The only reason you said CDR hose is because it's longer, right?
Longer.
Yeah.
Longer. That's affirmative.
Houston, we're trying to extend that commander's hose by use of the vacuum hose.
So, copy that, Captain.
Sounds like a good plan if you can work that out, Jim.
Capcom, okay, you're getting that from John Aaron.
Intro network on call. Procedure network on call.
Aquarius, if you can shake Jack loose there, I've got some procedures for him to write down.
Okay, stand by. Okay, Jack, is this a long one?
Oh, it's about 12, 15 lines. It's a matter of verifying some valves and so forth.
Okay, go ahead.
Okay, we want you to go in when you can and verify the following valves and leave them as we outline here. Repress package valve, off. Emergency cabin pressure, off. Direct O2, off. Demand reg, off. Both water accumulators, off. Main reg A and B, open. Water and glycol tank, inlet and outlet, both. Now if you want to get some water, we recommend that you momentarily turn the surge tank on to pressurize the system and then turn it off and take out water as required. Over. That's it, Jack. Another note on taking water. If you don't drain enough water so that... Say again, Aquarius.
That wasn't us, Jack.
Okay, one more note on the water, Jack. If you don't bleed the pressure off when you don't take enough water to bleed the pressure off completely, the pressures that left on there is going to drain away in a period of 1 to 3 hours. So it's a small amount of oxygen, but we might as well save it. So if you want to eliminate that problem, you could completely drain the pressure off by putting the water in a water bag and saving it that way.
Okay, that's a good idea.
So that's the end of my line.
What
Go
I'll
ahead.
do, let me repeat. Okay, let me repeat it all back to you. Repress package valve off. Emergency cabin pressure off. Direct O2 off. Both demand rags off. Both H2O glycol accumulators, water glycol accumulators off. Main rag A and B open. Water and glycol tank inlet and outlet open. For water, momentarily pressurize the surge tank. Take out water as required. You're recommending drain out all the water until I can't get any more water out of it in order to conserve the oxygen.
Okay, we just want you to turn off the water accumulators and not the glycol accumulator, over.
Okay, these are the water accumulators on 382, right?
That's affirmed, the accumulators on 382.
Control flight. Go ahead, Mike. Is that one of your RCS heaters or something that keeps cycling that 4 amp load?
Yeah, probably. Right.
Don't you think it is?
IMU probably.
IMU maybe, or a combination of the two. What kind of duty cycle is that got? It must be on 50% of the time. Isn't it, approximately?
About 17 or 18%. You know.
Is that all? I guess I'm just staring at it too long or something.
Well, with this present profile here, we'll probably have to power something else down here after the burn.
After the burn?
Yeah, we make another burn at 80 hours.
Yes, we will. Okay.
Okay. Capcom flight.
Go ahead.
Jack, I dumped, now, are we okay on the hoses and the CO2? And the comm on the cable? As far as you know. I heard him put the vacuum hose on the end.
I don't
But is
know.
this comm okay, or just one guy, they're using one headset?
I've been talking to both of them.
Okay, maybe pull it loose.
Think about this.
Fido flight.
Go fly.
Are you getting good track now?
That's affirmed.
Alright.
Look at 67 hours for vector.
Alright. Okay, a couple of things that are being entertained that I would like people to know about. Can I get an amber light to see if anybody's listening? Yeah, that's pretty good. Guidance, CCOM, GNC, control. Could I have your attention just a minute? Look, control, are you with us? Is he busy? Hey,
Go ahead, fly.
I just want you to hear something now. There are two things of some significance being discussed. One is that we can save a couple amps by turning the comm down, and at some point here when this thing stabilizes, clearly we're going to go to some kind of duty cycle on the comm. I don't know whether that's tonight or not, but that will happen here at some point in this flight. The second thing is that there's active discussion going on as to the pros and cons and the advantages of dropping the service module, perhaps prior to PC+2. and I'm not up on all the details of that discussion, but it's going on. You guys in the front room here ought to know about it, those of you who don't. It has to do with PTCs and thermals and saving a day, perhaps. Retro, is that correct? We save a day at PC plus 2 without the service module wait. Can you verify that?
Roger, flight. It looks like we can do that. We're getting the numbers final together.
But yes, that is an option, is it?
That is an option.
Okay. But is that to the MPL, or is that to somewhere slightly off the MPL?
That's to the MPL.
To the MPL, also. Okay, to my knowledge now, they're probably the most, and that second one probably even more so, significant subjects going around. Now you got a continual job here to be sure that we're watching this configuration. I want the guys thinking about what they want done from now on with the LEM. We got to consider powering this thing down. We got to think about mid-courses perhaps after the PC plus 2 and how we're going to do those things if we turn the platform down, etc., etc. We want to think about a check on the platform before we do PC plus 2, and I've heard that people are working on a sextant, command module sextant check, which sounds to me like a reasonable thing and probably not taking any power to speak of, or if any. Bob Collins raising his hand.
Yes, Gene, Glenn, the guys in the back are running this water profile, and right now it looks like it's coming in real tight.
Yeah.
And the water itself. And
assuming that we stay at this level from now on.
Negative, assuming we power down post PCT.
Okay.
Okay, now, so the Gatto guys have given me a profile here that I'd like to broadcast on there for the guys over in Span to start massaging and for our guys here to start using the common profile. And I hope that Gatto will update it in FIDO if there are changes to it. But here's the way it reads right now. At 7930, we've got the next dip burn about 850 feet per second. After that, we'll power down. Prior to that time, we'll leave the gear that's on right now powered up.
Yes.
After that time, we'll have a next burn that we don't know the feet per second delta V on it. It's at 92 hours nominal, the first mid-course. Okay. The next burn is at 140 hours. It's the second mid-course. Our intentions are to power everything down that can be powered down post PCT. And that means even the TM, the platforms, the LGC, the whole smash, but live support. Now doing that, they're going to come in just barely on the wire, and looks like it's going to run just about 150 hours or something on that order.
Okay.
Now, that's the profile they're working on, and I hope that everybody else in the building is working to the same profile.
Okay. I'd like to see someone start to keep now a continuous record of our, at any GET, what our current estimate of the water and the power, etc. is in the LEM, and I want that factored into the discussion of retaining the service module. I'm sure people are doing that. And when the people in the back room get somewhere, Gene C., let me put it on you. When the people in the back room get somewhere with that service module discussion, I'd like to start hearing it out here so the operators know some more about what the considerations are. You know, there are thermal ones and the shield is now open, etc. Okay, Bob, that's good. That's the current plan. Let's continue to refine the numbers. You ought to start dating, if you haven't already, GET, the estimates, and I'd like to start making some copies of those and getting them around. Now, you guys are running the budgets, tell me.
Roger, fine.
Let's start making a record of those, dating them in GET, and getting them sent around to the console so everybody in the room's got the same idea. Welcome with your assumptions on it. And again, put them on some channel somewhere so people can call it up if they want. I assume that there's a activity going on in the CSM area on what happened, and I haven't kept up with that in recent hours. I assume that's going on, and whenever it arrives at some conclusion that's feasible, I'd like to start hearing about that in the room here too, John, or whoever.
We're pulling that together.
Your console ought to answer to that. Okay, now, does anybody have anything else that they want the rest of the people to be aware of?
Party camp. I got the procedure here to power the iron heaters. If we get decided we should do that.
Is it?
That's firm play.
We'd like to
power the IMU heaters keeps what? IRIGs or PIPAs or both?
Both.
Okay, we have to power to keep the IRIGs?
PIPAs mainly.
Well, I mean, who cares about PIPAs?
Well, if you want to use a platform for entry and CNC
I can use the
control.
platform for entry without PIPAs. You know? So, is that what you mean? It's good for PIPAs?
That's right.
But we would still have the IRIGs?
I think that's true, but we'll have to get...
When do we have to make up our mind here?
Well,
shortly,
the
hourly?
problem occurs when you get down, as I understand it, it occurs when you get down at 40 degrees.
Okay.
I mean, stable member, and when you reach that point is unknown.
Mm-hmm.
And feeling is we haven't reached that point, but nobody knows.
Okay, did you guys entertain a discussion with the retro and the guidance about how much is it going to cost us?
Figuring that about a 50% duty cycle will be 140 amp hours.
Tell me you copy that?
Raj, 140?
114.
114, okay.
Okay, now, tell me, would you please quickly address this profile and in some short order here, give me some idea whether I ought to start doing that or not?
Roger.
Okay. I don't know how you guys feel. Pip is...
Flight econ, correction on that power number.
What
Get right
power?
back to you. The 114 amp hours.
Okay.
We'll get a better number to Telcom.
Okay. Okay, does anybody have anything else they want to bring to our attention? FAO, you've given us a sleep cycle for the pilots. You've looked at when we're going to be in the shadow of the moon. We can do a P51, 52 there if we like, right? And as far as you know, you got the cycle, the sleep schedule cycling, so we got the proper wake time for 79 plus 30, etc. Okay. Anything else, Bob?
Not at this moment.
Vince, anything you can think of? Okay. Okay, everybody, now let's settle it down and let's work the problems that we now have. Keep our eye on the configuration and yeah, and if anybody's here from the next shift, maybe they ought to get an hour sleep somewhere. I don't know if I recognize anybody from Jerry's team, but Johnny Aaron. Okay. Okay, everybody, would you go back green for me, please? So I'll know where we are. GNC, Fido, Capcom, back green, please. $64 amp hours it will cost me to keep the Pippas. Is that right?
The number I have flying is 60 amp hours.
60? I'll round it off at 65. 60 to 65 amp hours to retain the Pippas. And tell me, would you quick run me out your amp hour budget? Let me know if you can afford that.
Right, fine. Okay, flying, tell me.
Joe.
Okay, based on the fact that we power down the GNC stuff after the 80 hours, we're good 165 hours GET.
On it, current.
Yeah.
Is that with or without the 64 amp hours in there? It's without it?
That's with it.
Oh, with it?
That's with the this Pippas.
Oh, so. You're telling me we can keep those and still have a good margin, huh?
Yeah, if we power down.
Okay. To what level?
Let's turn all that GNC stuff off. Stand by. Flight, tell me.
Go ahead.
It's about 20 amps. 17 to 20 amps.
I'm sorry, I don't know what question you're answering.
Oh,
17, 20 amps. Oh, that's
I'm
what
sorry.
you're assuming to be the power down.
Yes.
Okay. Guidance and control flight.
Go, flight. Control here.
Assuming that you got a power back up to do a mid-course, you know how to do that? How are we going to do that?
You mean bring the platform back up?
Yeah.
Well, we've been looking about using the CSM optics to find out what the platform alignment would be in the limb. We could do that, I think. And,
Well,
CSM
okay,
guys
but
been-
we're talking about turning it off. Can we use the CM optics data to
when we bring it back up, right?
bring it back up and align it.
That's affirmed.
For mid-courses, it doesn't need to be but so accurate, right?
Right. We could just find out where it is with the CSM optics.
I see, and proceed from there, huh?
Right. What it, just use what it comes up with,
Yeah.
and just define a matrix wherever it is.
And you can resolve all ambiguities and know where it is from some optic shots. Is that right?
That's firm. From the CSM optics.
Understand.
And we've been looking at that and working on a procedure to get power to the CSM optics to be able to do that.
Okay.
ECOM and GNC have got a procedure written up for that already.
All right.
And we're looking at checking the limb alignment, how accurate it is prior to the 7930 maneuver.
Okay, so that's in summary then, it's no problem to take the IMU off, and then you have a fashion for bringing it back on.
Right.
Okay. Okay, and I'm still standing by to hear some more about the IMU heaters. Econ flight.
Go ahead, Flight.
I guess you and GNC ought to get together on some entry sequence, and when we power up, etc. With what we have here.
Firm, Flight.
And
we sketched out a preliminary plan, but we need to go back and verify all the numbers and verify the checklist. It's a big job.
Yeah, I know. Approximately how long before entry interface are you talking about?
Well, if you want the IMU, you got to start around 2 hours prior.
My question is getting around to, is it even feasible that we can get the IMU?
That's firm, Flight. I think we can.
You think we can? I don't want to spend amp hours out to limb to keep PIPAs, which I can't use. All right.
This is Apollo Control at 64 hours, 28 minutes ground elapsed time. To recap briefly the situation with Apollo 13, the crew in the last hour was passed up a paracynthian plus 2 hours maneuver, which actually is primarily a speed-up maneuver to get them back to Earth somewhat earlier than the normal free return would bring them. This maneuver would come at 79 hours, 27 minutes. Ground elapsed time would involve 845 feet per second velocity change. Splashdown would be in the Southwest Pacific, north of New Zealand, at about 142 hours, 47 minutes ground elapsed time. At the present time, the limb oxygen quantity is 50.6 pounds and 300 pounds of water on board. Cabin pressure holding steadily at 4.7 up to 5 pounds in both spacecraft. The tunnel between the two is open, so they share a common atmosphere. Apollo 13 now 193,700 nautical miles out from Earth, velocity 3,005 feet per second. Discussions here in the control room have to do with the power down procedures, how to conserve electrical power, the water used in the coolant for cooling the various electronic systems in the spacecraft, how to husband all of these consumables to get the most mileage from them. And at 64 hours, 30 minutes ground elapsed time and standing by. This is Apollo Control.
Flight control.
Go ahead, control.
Hey, can I take 2? I got Bob to plug in.
Yeah, okay. GNC flight. Jack, you're listening to all this. What do you think about the heaters? Would you like to try to retain the option to have that PIPUS? We can choose at any time to give it up.
I agree with that, Fly.
Not costing us any water.
I think we ought to bring them. I think we ought to fire them at least for meantime, even if it's cyclic.
The only trouble now is
we don't know what the cycle
over there to do it in the dark.
Right.
Any problem? Tell me, flight.
Flight, tell me.
I'm kind of being talked around to punching in the IMU heater circuit breaker in the CSM and hanging on to that capability for a while for a number of reasons.
Yeah, like I say, if we power down here, and I think that's what we're talking about, powering down the GNC after we burn, that'd be acceptable.
Okay. GNC okay?
Sounds good, Fly.
People say we got to punch it back in to save them, huh?
That's right.
Punching it back now, we're really doing some good.
Say
We're
the
not
PIPUS.
just,
I haven't got the word on the outrage yet.
well, with or without, these guys have an argument for retaining the PIPUS in the nav. Okay, Joe. You talking? We'll punch in the circuit breaker and IMU heater circuit breaker and retain the option. Yeah, to say. Well, wait a minute. Do we have to do anything else powering the bus? Powering the command module?
We got to do a lot of things.
Aquarius, Houston, go.
Oh, wait a minute, Captain.
Roger, Jack. We're asking whether a P51 and a P52 are required in the backside of the mountain.
I think so, Jim, but stand by while I verify it.
Guidance flight.
Go, Fly.
Are we going to require a 51 and a 52 or just a 52 when we get in the shadow?
We know where the platform is, Flag. Well,
You think just a 52? Is that what you're going to say?
yeah.
So we think just a 52 will do it.
Aquarius, Houston.
Go ahead.
We think we know where the platform is, Jim. The tracking looks real good from the last burn. We feel that just a P52 will be required.
Okay.
Oh, Ecom, you guys working out what we need to do?
That's fine.
Okay. Capcom flight, they're working something out. They'll write it up for you on the IMU heater.
Joe, has your continued tracking changed our paracynthian altitude any?
Fido, what's the current paracynthian?
Stand by, we'll get the latest on that, Jack.
Stand by one flight.
Okay.
Flight, Fido.
Go.
Okay, we're showing 137 right now.
Okay, is that on more data?
Negative, Flight. That's still on the old stuff.
What old stuff? Some tracking?
Yeah, the pre-mid-course maneuver. Okay, we're looking at 67 hours before we have our first update.
Okay, so you're looking at the confirmed maneuver?
Yeah. Yeah.
But the Doppler is confirming it?
Right.
Okay. Capcom, our estimate is still 137, and we'll have a good number after 67. That's when we're going to take a batch of track and compute again.
Aquarius, Houston.
Go ahead.
Roger, Jack. We're still looking at 137 miles, and Doppler's confirming it. We'll have a good update after 67 hours.
Oh, that's good. Hey, I want to say you guys are doing real good work.
So are you guys, Jack.
tell me you flight?
Go ahead, fly.
The thing you're using is average power. Is it the number of amps when those heaters are not on, picking it up for?
Well, it just averages the duty cycle.
Averages the duty cycle. And what kind of an average are you seeing?
About 27.28 amps.
Okay. $27 and $28. Tell me you fly.
Go fly.
And with our current power down plans, assuming you leave the comm on, what kind of average are we going to be at?
About 20 amps flying.
And assuming that I duty cycle the comm, what would I be at?
I mean, take it off?
I take it off and have to call us every hour.
Just a minute, fly. I don't think we worked that one out yet.
All right. And with the 20 amps, Merlin, what have I got on? Purely your ECS?
Yeah, that's primarily ECS and your comm instrumentation.
All right. Okay, well,
flight, we're working on this powering up the CSM right now. Could I get back with you?
Yes, go ahead.
Flight info.
Go ahead.
We'd like to propose a small little test here. Okay? What we'd like to do...
You know how I like those.
Yeah, I know, but this may save us some power if we can get it to hang in here. We're talking about turning the biomet off, going to low bit rate, down voice backup, and opening up the power amp circuit breaker, and seeing if we can maintain low bit rate lock. If we can, it's going to keep us in a low bit rate mode, but it's going to save us a good amount of power. Okay? Now, when later on when you yaw, we won't be able to hold it. We know we definitely won't because of the attitude we'll be looking at that Omni.
Okay.
But then we could entertain the thought of bringing up the steerable and maybe having to turn the heaters on, which don't pull very much, maybe about 0.2 of an amp. And the steerable actually would draw less than the power amp.
Okay.
And seeing if we could go there. But what we'd like to do here is to do this for about 30 seconds and see if we can get low bit rate in this mode. It's going to be very close, if at all.
How far are we from making our yaw maneuver in time control?
We're just about there now, flight. We're kicking it around, see where they wanted to do it.
While they kick it around, we can do this. It'll only take about a minute, at most.
I think it looks pretty good right now.
Okay.
Well, we've got it on paper here for the Capcom.
Okay, bring it over. If it doesn't work, we'll go right back. Control, I assume you're going to give me a GT when you want to go 90.
Yeah, right. Right now, temps and everything looks pretty good.
Yeah, in your ship.
Yeah.
Flight. Go.
Calm flight.
This is y'all. One thing I'd point out, if we go low bit rate, we don't get computer data, therefore there'd be nobody monitoring the computer alarms, etc.
Right, flight. If that one of those breakers open, he doesn't get the computer alarms on or the caution lights on his history. And we can push one of those breakers in, it pulls about 0.2 of an amp.
Okay. Do you understand that, Captain? Echo flight. One more time. What am I going to do by doing this test right now? When I'm going to do my yaw maneuver?
Well, if we do it before you do your yaw maneuver, we'll be looking at a good Omni. Okay, we do the yaw maneuver, we're down in between country.
Okay, but so we're looking at a good Omni. We're going to move in 2 minutes. So I'm not going to save anything.
Oh, yes, you will. See, then we'll know we can do that. Then when we move down, we can activate the steerable. Okay? Keep the power amp off. Use the steerable.
All right.
And save some power. That's
Okay,
what you're after.
Yep.
Right?
Okay.
Power and water.
You with me, Captain, on that list there?
I think so. The list is straightforward. I understand we've got the first yaw maneuver coming up in a few minutes.
Soon, yes, and we're doing this to see what we want to do when we go to the new position. It's possible that we would go to a different comm configuration and save some power. Okay? You understand what wants to be done there?
Yeah, I think so.
Okay. It's in the interest of saving the power that the power amplifier could gain us. And if it works, we'll end up saving an amp or two, which is worth it.
Okay.
Aquarius, Houston.
Okay, we'll try.
Go ahead, Houston.
Okay, Jim. We've come up with a COM recommendation, which we hope will save some power by powering down the power amplifier if it works. And I'd like to read up the steps to you and have you think about them for a minute. And we recommend trying it before the first yaw maneuver. Over.
Okay, you can read up the steps.
Okay. Step 1, biomed off. Step 2, go to low bit rate. Step 3, go to down voice backup.
Go.
Okay, about 65 hours GET. Let's
Step
rotate
4.
90.
Okay.
Power amp to prime. Step 5,
Thank you, Hal.
panel 16, power amp circuit breaker open. Step 6, range function switch off. Read those back to me and then I'll have a remark.
Okay, it's biomed off, low bit rate, down voice backup, power amp to prime, circuit breaker panel 16, power amp circuit breaker open, range function switch off.
Okay, and the note says that you should be able to hear us. If we can't hear you in a couple minutes, you should close the power amp circuit breaker on panel 16. And we expect to save an amp or more on this. It should work in the present attitude. When we go to the new yaw attitude, we're thinking about powering up the steerable, leaving the power amp off, and if we can get good COM in that mode, we'll still save some power. So if you concur, why don't you go ahead?
Okay, in this mode, you should hear us, or we should hear you, but if you can't hear us, then we ought to close the power amp circuit breaker again. Is that right?
That's affirmed. We'll just run a little COM check after you get done and see how we're doing.
Okay, fine. And if that all fails, we'll go back to our original configuration.
That's affirmed.
Okay, let me run it through the mill. FAL flight.
Go, fly.
Charlie Duke and others are suggesting that we consider trying a technique of P-52 with the Earth and the Sun, which takes certain angles, etc. And for all I know, we may be very close to it at either this or the next yaw attitude. This would give us a leg up on whatever we might run into with a P-52 in the shadow. Okay. In other words, we might notice it work. We'll get it up there right now. Once we run that through and see what it takes to do that.
Power amp primary. Power amp is at primary. Okay. Circuit breaker 16. Power amp circuit breaker open. COM. Power amp circuit breaker open. Only one. That ready? Yep. Range function switch off. It is off. Where? Yeah, it's off. Is it?
reachable, right, Captain?
We were reaching with a lot of noise. The noise seems to disappear now. Can you read this better?
I didn't copy your last remark, Jim. I heard that you had a lot of noise in the background also.
Okay, here's the Aquarius. How do you read it now?
Just the same, Jim. You're readable, but it's very noisy.
That time is usable, and it ought to be better when we go on high gain. Ought it?
Okay, we can still read you. Do you want us to remain in this configuration?
Yeah, let's leave it there for a while.
Stay there for the next minute or two anyway, Jim, while we evaluate it.
Tell me your price.
That's about a 25 amp.
Okay, I can stand a little noise in my ears for 2 amps. For 1. That time, I'm sure you can. Can't you still? I think just reading it's alright. When you got to.
That's great, sir.
Okay, I tell you what we need, Jack. Besides getting this squared away again. We need to get some push to right procedures here. Line and procedures, the whole works before we can all follow up here. Yep, okay. Let me get something.
So, that time is probably just getting by. We have to redo any real talking when I'm going to use that. I'm with you. I understand it. Let's see. We're at 5 minutes from the new altitude. I guess it doesn't matter when we go there, does it, Patrol? Do we want to go there and try the high gain procedure?
It's one we can use. Say what for dip bird. Where's the jump? Get a clip and it goes on my side there. My
UNC's flight.
gotta get a clip. They're
Sure, Glenn. When do we have to push that circuit breaker in for you, do you know? Is there any way to estimate? The reason I ask is it's a long procedure, requires getting out a big drawing and flashlight, and I don't know.
we should have some around here somewhere. Yeah, they're back.
When would you like to have it pushed in, or can't you answer that question?
Here.
Well, as soon as possible. Yeah, as soon as we can do
Oh,
it.
here they are.
Say again?
As soon as we can do it.
Yeah.
Because the longer we wait, the lower the temperature's getting.
Okay.
Put that right up there, just like that.
Okay, control, okay, Capcom. Probably time to go to the new attitude of, if you got instructions, what do you want us to do?
Yeah, all you have to do is,
Control, we just, you already united, right?
yeah.
I was talking about the time business. I don't know whether they go back to an army or back diagram or whatever, but I wanted you involved in that. So, I wanted you to do it, I guess. Does that procedure tell us, does that tell us when to do that relative to the yaw maneuver? FAO flight, control flight. So we're going to have yaw 90, but he's probably going to ask you for a number. Is it just as simple as 90 degrees from where he's at now?
yaw at 1.5.
Okay. Okay, Joe. Control flight, good. You might suggest to people that we start a procedure where we roll this thing something a little more or less than 90 degrees, so we kind of don't have every both off 4 hours, the same thing looking at the sun. We kind of split it around a little bit, yeah.
I'll see a little having you input for now on that.
Yeah. Whenever you're ready, Captain. Before you work that CSM umbilical thing, how about the, we got a yaw now, you don't want to put out a high wind.
Okay, Jim.
Start keeping a log of all of the features.
Is that a yaw rate, man?
Are you all right, man? You got all right, Ken? Okay, so, okay, okay. You all right? I don't think it's
Oh,
noise,
copy
does it?
down the one, we got the
Is that
water.
what we're expecting, a yaw rate? That's what I was expecting. Is that what Enco was expecting with this procedure, is a yaw right?
Aquarius, Houston, over.
Enco flight, you expecting a yaw right?
Roger, flight.
Go ahead, Houston.
Okay, speak slow because there's a lot of noise in the background. Have you completed your first 90-degree yaw maneuver? And if you haven't, we recommend it, over.
Okay, we have not completed it. We will start. We want you to monitor the maneuver, over.
Okay, Jim, and I want to pass you up a short procedure for activating the S-band steerable antenna, which we'd like you to do after you complete the 90-degree yaw. Are you ready to copy, over?
Ready to copy.
Okay, first on panel 11, close the S-band antenna circuit breaker. Then go to activation, page 28, steerable antenna activation, and complete steps 2, 3, and 4 of activation 28. You'll have to do a verb 64 to get the pitch and yaw angles. And the last step is on panel 16, S-band antenna heater circuit breaker to close. Over.
Now, Joe, we didn't get all of that. We just have complete step 2, 3, and 4 of activation. Is that 68 or 28?
Jim, that's...
Do a verb 64 to get...
They don't have it on. That time you better disregard that and go back to mine. Which
Aquarius, Houston, that procedure I just passed you, please disregard it, over.
Fido?
After contact.
Disregard it. Okay, do you want me to start my yaw maneuver now? And I'll be yawing to my right.
Okay.
Clockwise maneuver.
Roger, right yaw is acceptable, but wait 1 before you start the maneuver.
Roger.
No, let's try it later.
Okay, what?
Yeah, let's go see how we can do on the Army at the next altitude.
Okay, Aquarius, Houston, you go to commence the yaw maneuver.
You don't fly
With the
that
present time configuration.
You're on the wrong way still.
Aquarius, Houston.
Go ahead.
Okay, you are go to commence the yaw maneuver. If we don't have COM after you complete the yaw maneuver, bring the power amplifier back on, over.
Roger, understand. We'll start the yaw.
Okay.
Tell me, bud.
Control flight.
It'd probably be a good idea to start keeping a status of exactly what we have on there. Okay? You know, what equipment we have on.
Right.
And have it on some television channel that people can go refer to if they want.
Yeah, right.
But, you know, listen to what equipment they're on.
Yeah, we're presently holding this procedure. Tell me how many minutes you said.
I didn't hear all this you said, John.
This procedure on the Dolphin, Kelly, got another input for it, so we're holding it on the test.
Another input. Okay?
Like this.
Go ahead.
Just remember, Jim, that nobody's monitoring the kitchen lights.
That's right. Control flight. Go ahead. What circuit breaker do we need to punch in?
Okay, panel 11, row 3, the last one on the right, on the ladder, annunciator dot component line.
What's the name of it?
Annunciator dot component. Panel 11, row 3, last one right hand side.
When we put that in, have we kind of swapped ourselves, and are we even on the power? We still might save some.
Yeah, that's about 2 things in that.
Okay. Captain on play. Captain on play.
Go flight.
Joe, you understand that the crew has pulled a circuit breaker which doesn't allow them to see program lines right now. And with this test, we found that, of course, the test being low bit rate, we're not being able to monitor the computer on the ground. So for them to monitor the computer program lines, they're going to have to punch in the circuit breaker on panel 11, row 3, last one on the right. Annunciator, stop, component. That doesn't sound right to me. Annunciator what? Control? What's the name of the circuit breaker? Annunciator what?
Annunciator slash stop slash component.
What's that middle word?
Stop, D-O-C-K.
Okay, that's what I thought you were saying. We're going to need that circuit breaker in order to watch the program lines, because we can't see them.
Right now. So do you have a recommendation for him to monitor this periodically?
Yeah, that suit me. It suits him.
It suits me fine.
Guidance, okay?
There are a number of things on that flight other than program alarms. Temp lights, gimbal lock warning, restart light, operator error light.
Joe, do this. When we get to the new attitude, if we are satisfied with the time and are going to stay in this low bit rate, Dad advised me to punch that up for the things that Charlie Parker just rattled off. Okay? Let us evaluate that when we get to attitude. Control flight, how close are we to getting attitude?
You'd only need something like 10 degrees or so.
Okay.
I guess I'm not clear on that yet, whether we want them to punch that circuit breaker in and leave it in, or to remind them that they need it for program lines.
Joe, since we have a power in Bob,
Bigger and bigger, Jack. It's over here now.
and we're waiting to see how good the time is at the new yaw attitude, if it's good and we're satisfied with it, we would recommend punching that circuit breaker in so that he would have those lights, because we're on low bit rate, can't see it. So, yeah. Yes, sir?
Yeah, I'd like to hear the
list of items. Guys, can you get a caption, please?
It's the overtemp, the temperature alarm, gimbal lock warning, program alarm, restart, operator error, uplink activity. It's the DISCI panel.
The DISCI warning line.
Right.
Did you get the description of the circuit breaker section?
us to transfer this CSM power to the air power, we're going to have to turn on the Aspen battery and push this, so we better do that now.
Oh, boy. This gets longer and longer, doesn't it?
Yeah, so you want a copy of to do this.
Say again?
You want a copy of this statement, a couple of steps to the side.
No, I want all the procedure written out together there.
Okay.
I'm beginning to wonder whether it's worth it. But we have to advise them about it.
Somebody said that,
Control, are we to attitude yet?
Say again, Frank?
Are we in attitude yet?
Yeah, you just got about another 70 degrees.
Okay. John? Joe, I don't want you to read anything up on that London umbilical until I hear a complete review of that. Okay?
All right, doesn't even have the procedure anymore. They pulled it back.
Being lengthened.
It's long enough right now with all these difficulties.
Well, not only that, it turns out they have to pull the descent back off, precondition the ascent back. I don't know, I've just heard enough that I want to re-review that whole procedure if we do. Okay. No problem with dialing. No problem with dialing. Right answer, yep. That's one step.
In regard to the enunciator, on the dispute, we told him to push that brake on panel 11.
We didn't tell him that yet.
We haven't told him that yet?
No, we didn't. We kept him. So we were waiting until we got to attitude. We didn't tell him about that enunciator.
Okay, very good.
Go ahead. Where's the second to it?
Okay.
What is it?
If you're just going to push the warning, then you need to confirm a switch of this mode. If you push both of them, then you don't have to worry about a switch configuration.
Which both? 1 and 11 and 1 and 6?
Yeah.
Okay, Captain.
So I recommend just push them both.
Okay. what they've inputted.
Houston Aquarius, did you call?
Negative. Houston, we do not call. How you reading us?
Get that front time, turn that in, and then we'll take off.
And Houston, can you give us an approximate time to turn off the SN02 in case you lose voice with you?
SN02, W, it's down now, isn't it? It's right,
Roger, Jim, I'm copying about half the
it's back to descent. You can go back to descent 02, Captain. So you can, this question was, can you go back to descent 02? And the answer is yes.
Time to go back to descent 02 in case we lose communication with you.
Affirmative. Go back.
Jim, Houston, that's affirmative. You may go back to descent 02.
Roger, going back now.
Telling you we're back on descent 02.
control. Rather noisy communications at the present time on the air-ground circuit to Apollo 13. Meanwhile, the Spaceflight Meteorology Group of the Environmental Sciences Services Administration has issued forecasts that weather conditions would be satisfactory for Apollo 13's landing in the Pacific Ocean next Friday, April 17. Along the planned recovery line in the central South Pacific, skies will be partly cloudy with southerly winds at 15 knots.
Joe. We haven't gotten an update on it.
Seas up to 4 feet are expected, with temperatures near 80
do we
degrees.
Wake up and swap people for sleep?
69 hours flying.
69 hours. Gene C. It is beginning to look like
Apollo 13 now 195,375
without having all three people
nautical
up.
miles out from Earth.
69 hours.
Velocity 2,981
that would save
feet
the
per second.
Pippas, and please don't
At 65 hours 27 minutes ground elapsed time. This is Apollo Control standing by.
Because I don't want to spend the power on it if they end up doing shit. Okay? And the reason that I think we ought to wait is because it's a fairly lengthy procedure. It involves battery work in the land rocket configuration work, and if we had a thread and gas up for it. Which puts it at about 69 hours. So, find out. If that's not going to save them, let's just not worry about it. We have to go through this procedure anyway at some point, though, just to have available land power to the CSM for whatever purpose. For example, optics tomorrow. If we want to check it.
Here's White House. I don't see any problem going 16 hours if we were this one already. Say again, I don't think there's anybody going to tell you that we're going to get down to 40 degrees.
Okay, well, would you work it? I'd like to, reasonably firm answer that that's the case.
How's that feel?
Because if it isn't, there's no sense. And if we get a good chance of getting them, and we have to go through all this anyway, okay, we'll probably spend the money. It wouldn't hurt to put that new word, put that on one piece of paper. Because you got to put the places where you got to wait. Merlin, tell me from this procedure annotated where you wait for the precondition.
It just says wait.
Okay, just so it does say wait.
Get it just a little closer, Chuck.
Control fighter, anyone near attitude yet?
Oh, we're about another 16 degrees to go.
Okay. Let me know when you're ready, okay?
Right. How much of that stock was today?
Don, I know you've got talking me off and on. Do you need to know anything from me? Assume it'll go either way. Okay?
We got a cap?
Good. I'll review them with you here in a little while. We got one noticeable together.
Sergeant, Phil.
Yeah.
We'd like to try one more thing on the sound. I think we can improve the voice.
Okay.
It's we want to go from normal voice in the lamb. Function switch to voice.
So we do that now.
Yeah.
Function switch to voice, and you think that'll improve it?
Yeah. And if we don't, if it doesn't improve it, then we'll go back to down voice back.
Okay.
Aquarius,
Like
Houston,
pro,
say
we
again,
are
please.
Okay. Capcom,
we have a radio check on our new attitude.
have them go function
Okay,
switch
Jim,
to voice.
we copy the angles. How are you receiving the voice now?
Your voice is excellent.
Okay, real good. You are clear. We still have a lot of noise, but if you talk slow, I think we can manage.
Capcom, they want to try to function switch to voice.
Crank up that high gain.
To improve the noise.
What was that high gain they cranked up? Right now. That's it.
Capcom, flight. They want to try to function switch to voice to try to improve the noise, Jeff. They want to try function switch to voice to try to improve their voice, improve the noise. Okay? If it doesn't work, go back.
Aquarius, Houston, over.
This is Aquarius, go ahead.
Roger, Jim. To try to improve our comm down here, we'd like to try going function switch from down voice back up to voice. Over.
That is down voice back up. Function switch again. Function switch going from down voice back up to voice.
Roger that.
Sergeant, Phil. Let's do a voice check now. Let's do a voice check now and see if we can improve the range.
Capcom, you want to try now and see if it's any better?
How do you read now, Jim?
I'm not reading them now, so you all want to go back.
Yeah, you better go back. Don't think so?
Let's do it one more time, flight. Have them give us a count.
Capcom, see if you can get them to give us a count.
Aquarius, Houston, request a short count, over.
Sergeant, Phil, if it's no go, it's about the down voice back.
Okay, Capcom, back to down voice back. Back to down voice back.
Aquarius, Houston, we're not reading you at all. Request you go back to down voice backup.
All the way? Yep. Houston, Aquarius,
we're on low bit rate and cannot monitor him, and he ought to have those two signal digits in there. Have that space. And anytime he wants to get clear, he can push him at car amplifier, right?
Okay, Jim, since we're in low bit rate now, we cannot monitor the diski for program alarms, etc. And we recommend that in order for you to do so on board, you push in the following circuit breakers on panel 11 and panel 16, the annunciator / dock / component circuit breakers. That will allow you to monitor your diski warning lights, over.
Roger, Houston, would you say one more time for circuit breaker?
Okay, Jim. The circuit breakers are the annunciator / dock / component circuit breakers on panel 11, third row, far right under lighting, and on panel 16, also under lighting, second row, third from the left, over. Okay, real good.
flight? Or Fido flight? Pinto flight?
Go flight.
What do we have LOS on the moon? What's GEC first? Or AFD, have you got that handy there? When do we have LOS on the moon?
This is Apollo Control, 65 hours, 45 minutes,
Give me
ground
a
elapsed
GEC,
time.
I can add that.
Communications rather scratchy at this time. Go
Looks
back
like about
over the
77,
past
10
8 or
flights.
10 hours of the mission. The problem first cropped up at about 55 hours, 58 minutes, ground elapsed time last evening when the crew first reported an under voltage alarm on the command module.
We're coming
main
up
bus
at 6 to 6 hours
B.
GET with another handover from
This was
Honeysuckle
their
to Madrid.
first
And I
hint
guess
that
we're going to be
something was
using the
amiss.
same procedure we
The
did
pressure was
last time, in which we will have the
rapidly
man
dropped
turn the
in,
transceiver off for 5 minutes.
in the service
you tell me
module
when you
liquid
wanna do
oxygen
that.
tank
Capcom
number
flight?
2 and fuel cells 1 and
Capcom
3
flight?
failed shortly thereafter. A decision was made to scrub any attempt at
Flight
landing
Capcom?
and continue on a lunar flyby.
We're coming up on a side handover at
Deep
66
space abort
hours.
type mission.
I'm not sure I can
The
explain to you
increased
why,
load on
but the
fuel
crew is
cell
supposed
2
to put the
and
S-band
the
transmit receiver switch
dropping
to off,
pressure
right,
in the
Nico?
remaining
And for
liquid
5
oxygen
minutes while
tank
we're doing that. And it has to
led
do
to
with,
the decision to
with
use the
being
lunar
able
module
to
for
lock up on the right
a
vehicle,
sort
not
of
be
lifeboat
confused with
to
the
come
IU,
back to
doesn't
Earth
it?
using its
In some
consumables
simple
for life support.
terms, so that I'm with you. Yeah, and we did this last time. We had a sight handover, Joe, and
The
that's
remainder of the
reason
evening
Okay,
was
could I have a
spent
time to shut it
in
down and a time to start it up?
trying to get
yeah,
power
we have a
and
handover at 66.
water
What time do you want
profile
this to occur
pared
there,
down
Nico?
to get the
6 to 6
most mileage out of
even flight.
these
And bring
items.
it back up 5
What
minutes
time do
later.
you want us to turn the the
And
transmitter
at
receiver off?
61
about
hours
half a
and
minute,
30
a minute before that
minutes,
Okay. I
ground
wouldn't
elapsed
bother
time,
calling now,
a
Joe. Wait a while.
38
Lead
feet
him
per
into it.
second mid-course correction burn
Okay, turn it
using
off
the
at 59
descent
and turn
propulsion
it on at
system of the lunar
04.
module.
Yeah.
Put the
Okay, when's
spacecraft
AOS,
back onto a free return trajectory,
AFD?
which,
When's
if nothing
AOS?
more were done, would cause the command module to re-enter the Earth's atmosphere in the Indian
Probably
Ocean
30
south
minutes.
of Mauritius
Flight
in
network.
about 152 hours ground elapsed time.
Call
However,
flight
network.
another
We would like
FIPS,
that
or
transceiver
descent
turned off
propulsion
exactly
system
at
burn,
6
is
to 6
being
hours.
planned
Even
at
and back up at
approximately
6 to 6 hours and 5
79
minutes
hours
each.
27
We will
minutes
oblige
ground
you.
elapsed
Got
time
that, Capcom?
with a
Copy that,
velocity change posigrade of 845.5 feet per second, which would bring the spacecraft home somewhat more rapidly. About 10 hours sooner, as a matter of fact, to splash down in the southwest Pacific at 142 hours north of New Zealand. And that's where the situation stands at the moment. We'll be handing over to the gold team shortly here in Mission Control. And at 65 hours 49 minutes ground elapsed time, this is Apollo Control standing by.
We would have a position at 77 plus 30. Why don't you assume 20, 30 minutes, you know? Start looking at 78 hours. Final flight. But I would like you guys down there to have a PC plus 3, stand by also, okay? That's TC plus 2.5 or TC plus 3, whatever you can get.
Roger that, flight.
And guidance flight.
Go, flight.
Look, we've been up there talking about the possibility of running a P-52 against the Earth and the Sun. My concern with doing it is what all we got going on. I have to do some powering up now and maneuvering, etc. to do it. I don't have any indication that my P-52 isn't going to work out just fine. In which case I would propose that we just kindly do the P-52 in the shadow as we are planning. We see, by the way, we ought to know, we see most of that before LOS. And when it comes out after AOS, he's 2 hours prior to the normal PC plus 2, and I'd like to have a PC plus 3 standing by. In case we have trouble with the P-52, we could try this procedure. We'd have all the numbers standing by, etc. Is that Brenda?
What, the ocean we are in?
Stand by. Ocean, stand by, guys.
The rendezvous radar antenna is now in the way. You might think of a procedure to get rid of it with minimum power, and maybe we'll be able to see stars with a couple times lower detail.
Okay, Jim, I think I understood that the rendezvous radar antenna is in the way and you'd like a procedure to get it out of the way. Is that right?
That's affirmed at the proper time and with minimum power.
Okay. Control, tell me.
Roger, understand. We'll work that.
Write down the procedure with minimum power expenditure to get that rendezvous radar out of the way, and any other power items to do the P-52, like, for example, the AOP lamp. Okay, and whatever else. Let's write them out for them, the minimum power procedure to do the P-52 with all the steps, okay? I don't mean write out all the steps, but the preparation that has to be done, etc. Okay, fine. And I guess I've just sort of talked people into delaying this Earth-Moon thing, Earth-Sun P-52, so we see if we got a problem, and we'll have a PC plus 3 standing by. Inspector, I'd like some idea of the sensitivity of that. Inspector, flight. Go ahead, flight. Can I do PC plus 2 and then PC plus 3 at essentially not any increase in cost?
Okay, yeah, now the PC plus 2 and 3 that you're talking about landing at 142, is that coming in? That's with a service margin intact.
To the best of my knowledge right now.
Okay,
but that might go the other way.
Now, the service module off, you're going to have to almost do it at PC plus 1.
1?
Or 1.5. If you're going to try to save anything for slot.
Would you please lay that all out? I'd like that to be clear. I'm not going to be able to solve that on this ship, but I'd like it to be clear what exactly we got to do to save a day by dropping the service module. Because I don't want to find ourselves in a position where we're all out of propulsion.
I agree. Okay, we'll do it.
Okay, FAO flight. Go fly. Have all the Earth-Sun P-52 stuff standing by for post-acquisition, okay?
Roger.
Quite a day.
basement and
Flight Noah. Go ahead, Noah.
How's Capcom cruise school and turning sensor going?
Oh yeah, Capcom, we're 2 minutes away now. We want them to turn the S-band transmitter receiver switch off. We have a handover, turn it back on. Turn it off at 66 hours, back on at 66 05.
Okay, that's the timer. That's where we know.
I don't know, is that the right terminology, Nico?
Flight point.
Okay.
Aquarius, Houston, over.
Go ahead.
Okay, Jim, we have a handover coming up on the hour. That's in a minute and a half. On the hour, we would like you to turn the S-band transmitter receiver switch to off. And 5 minutes later, turn it back to primary, over.
Okay, Houston, surely you wanted to turn the S-band transmitter receiver to off. 5 minutes later, turn it back to primary.
That's affirmative, Jim. After the handover, apparently they want to make sure that they lock up with you and not the IU.
Roger, let me know when you want me to turn it off. Check.
Raj, you can turn it off now.
S-band transmitter receiver. No, not yet.
Flight Noah.
And Houston, when do you want me to turn that S-band transmitter receiver off? On the hour.
Aquarius, Houston, turn it off now.
Turn it off now.
Okay, everybody, we are in the handover. The crew has turned off the transmitter receiver for 5 minutes. They will reacquire us then. The new team is beginning to come in, I believe. So spend some time now passing on to these new guys what you've been through here tonight so that nothing is dropped down. I want to be very careful about passing all the info and everything that's still open that needs to be resolved here before anybody goes off shift. As a matter of fact, hang around for a little while until Jerry Griffin goes through the team briefing to be sure that your oncoming comrade has got all the facts. Got it? Thank you. Fido flight.
Hello.
Tell me the Doppler's still confirming the confirmed maneuver, please.
Roger, it's doing that. I just checked. We're 6 cycles.
Okay,
Looks
that's
good.
essentially trivial, right?
That's affirmed.
And we are confirming the confirmed maneuver.
That's affirmed.
Okay. And all the guys who were here last night, starting with retro and guidance and control, and tell me your GNC and ECOM. I don't want any of you guys to leave until I've talked to you. Okay? Got it?
Got it. ECOM, got it.
Thank you.
Flight, was that all you want to tell those guys?
Say again? I want Tom Weichel around.
Tom Weichel to stay. He doesn't listen to Luce now.
Yeah, I want him to stay. I want to see him later.
Okay.
And I want him to put together, Tom, put together all the options that we've been over all night, will you please?
Right.
Like them all on one piece of paper. I know you've tried to do that for me a couple of times, and I just haven't had time. But I think I know what the main ones are. I'd like to hear what some of the others and the exact numbers are, etc.
You mean
including the ones associated with dropping the service module. Okay.
Okay, you want the options that we were going over before we did the mid-course?
Yes.
With and without the mid-course?
Yes.
Okay.
Plus the ones that have been introduced now since we've done the mid-course.
Right.
Capcom flight.
Go flight.
Joe, we have here the combined procedure for being able to power. John Aaron's got it. He'll give it to you here. For being able to power the CSM from the limb. Now, the one thing that is being considered right now is powering the IMU heater to retain the PIPAs. We would still have the IREGs and the attitude reference even if we don't push the heater circuit breaker in. Secondly, we have this discussion of using the CSM optics as a check or backup or different technique for the upcoming alignment that we have to do again for the burn. Thirdly, we may have some subsequent uses for the configuration, like for example, when we get to entry, if we got a lot of amp hours left in the limb, we'll probably recharge battery A, which we will be able to do off main bus B. The point of all that talk being that we are going to want to at some point configure the cockpit, although it's a lengthy task, to be able to power the CSM from the limb. However, in talking it over last night, I don't know if it was with you or Jack, we concluded that with the work that's in there with the batteries, you need Jack Swigert and Fred Hayes awake. And we wouldn't do it until they were both up and ready to do this thing, which is scheduled about 69 hours. And all else being equal, which I think it is at this point, we would recommend that they go through this procedure when they're swapping positions in the vehicles. Okay? When the two guys are going down to CSM slate.
Okay, let us look at it, Flight.
Why don't you look it over?
It looks like a long procedure.
It is that.
Has the trade-off been made for the backup P52 of using a few amps out of the battery and saving this until after the maneuver?
No, I don't think it has.
Okay.
It's that plus the IMU heater circuit breaker. If at some point we don't get that punched in, and nobody knows for sure when, although they feel confident if you punched it in at 69, they'd be okay. You may not get it back. Or you may get it back to grid.
Flight network, please check. Hand over complete.
Okay, and this should be here in town.
Yep, we have 11 data flight.
So Joe, I'm still not sure when we really want them to do that. GNC flight?
Right.
Have you gotten, you're telling me 69 is okay. Is 79 okay? So that I don't have to change my configuration before the burn?
And I assume we have comm, over.
I don't know that, Flight.
Pulse it, please.
We're still trying to get a handle on it. If anybody knows what it is.
Aquarius Houston, copy that. It's noisy on RN2. Stand by while we think about it.
And so why don't we just have them punch in the power amplifier for now? Okay? Inco flight.
Flight Inco. Right. We don't have solid uplink launch yet here, it appears. On the lounge. We got the downlink, so we don't have a solid uplink yet.
Okay, what do you think? Put it on or not?
Yeah, we can put it on.
Captain, I want you to suggest putting it on so you can observe your time for a moment.
Jim Houston, I think you just called, but I didn't copy.
Close the power and circuit breaker valve will be.
What?
Close the power.
The power and circuit breaker, yeah.
I don't know, Flight. I mean what that is, but I hate to try and read them up a long time.
Oh, don't do that.
With this kind of time.
Well, you're not reading anything up right now anyway.
I know, I'm just looking at the pieces.
Yes, have them punch it up and just say hello and... did you hear it suggest punching in the power and fire circuit breaker?
I did. I didn't hear what you were thinking right now.
Yeah, go ahead and do it and establish time and everything looks okay here.
Okay, if time is good, can you leave it in or do you want to pull it out?
Leave it in for a little while and see how they're doing, and we can save 2 amps when they pull it out, although I realize it's a lot of noise.
Okay, I'll wait for you to come.
Aquarius Houston, over. Jim, recommend you push the power amplifier circuit breaker on panel 16 in, over.
Roger, power amplifier circuit breaker panel 16 going in.
Okay, Jim, how is the comm now, over?
A lot of background noise. Let me turn off squelch.
Okay, you're quite a bit better.
Whenever I enable squelch, I lose you, over.
Roger, stand by.
Normal leave it
You're
off?
much better downlink.
Think so?
Roger, flight leave it off.
Okay, have them leave it off, Jim.
Okay, Flight Captain, I'm not sure we're in quite the ideal configuration yet.
Okay.
Let's get down 65. Okay.
For instance, we might want to go back to primary on the voice switch.
Yeah, flight until we can go back to normal voice here now with the power amp on.
Okay.
So we have a little bit more.
Okay, we want to tell him back to normal voice?
Yeah, function switch to voice.
Okay, Captain.
Okay, Jim, this is Houston. We recommend that you set the function switch
probably get some high
from
voltage
down
too,
voice
flight,
back
if
up
need it.
to voice, over.
Yeah, we'll have to look at the sound right.
Roger, function switch going from down voice back up to voice.
That's better.
Oh, no.
Okay, Jim, how's the comm now?
Function switch to this one. Still a lot of background noise, Joe.
Okay, we'll look at it some more. Your comm down to us is excellent now.
Go ahead.
Okay, our voice is good, but Jim still has a lot of noise in the background.
Understand. Enko, anything we can do to clean his up for him?
Yeah, we're working on that flight.
All right.
This is Apollo Control. Handover from the black team headed up by Glenn Lunny to the gold team headed up by Flight Director Jerry Griffin is underway at the moment. We're anticipating within the next several minutes change of shift press briefing in the News Center auditorium or News Center briefing room, which will be localized to the briefing room only. The air ground will be left up on the PAO release circuit. We understand it will be in the big auditorium. And further advice of the time of this and participants of this press conference will be forthcoming. This is Apollo Control standing by.
Houston, Aquarius.
Aquarius, Houston, go ahead.
The noise we're experiencing is similar to what we had sometime before when you switched stations.
What do you say, Joe?
I think he got cut off halfway through.
Roger, Jim. INCO is checking into what we can do about the noise. It may be a problem with the new site.
Roger.
Aquarius, Houston. Is the noise any better now? Over.
This is Aquarius, negative.
Roger.
Flight captain.
Go.
Just status that Jim has still got a lot of noise.
I understand it.
Okay.
Flight retro.
Good.
Let me point one thing out to you about this super fast return with dropping the service module.
Yes.
1 degree of pitch on misalignment. If it's pitched up a degree, it'll cost you 40 or 50 foot per second mid-course. If it's the other way, it'll cost you almost 160 foot per second mid-course.
In other words, the high-speed return is pretty sensitive to alignment.
That's affirmative flight. And I don't know how, like I say, you know what the problem is with alignments. It's
Yes.
very sensitive.
Yes.
Those are kind of round numbers, Glenn, but they're close.
Okay, Chuck, I copied that. Thank you. In other words, 1 degree of pitch will run you anywhere from 50 to 100 feet a second, depending on the direction it's
50 to 160.
in. Excuse me. 50 to 160.
Yes, sir.
Tell me, Flight.
Go ahead, Flight.
How much water's in the Bliss? 8 pounds per Bliss?
Raj, Flight.
Okay. Okay. I'm catching Jerry up here, so I hope you're getting your comrades up to date, and we'll let them have their team briefing. Then I want to see everybody after Jerry's got his team. I want us to all sit here to be sure they got everything right.
Yeah, we're briefing.
Flight from control.
Go ahead.
We're just about due another 90 degree yaw right.
Okay, Inco, are you standing by for that? 66 hours. All right. 30. FAO and Inco.
Flight Inco.
Full flight. You ready to do a 90 degree yaw?
Yeah, we're seeing some
Roger,
20s
flight.
on our uplink signal strength
Time.
flight. That may
Should
be
be
why our problem.
177, y'all.
Say again.
177.
Okay. Okay, are we ready to do that, gentlemen?
It'll be forward Omni on that flight.
Houston, Aquarius.
You ready to do it,
Aquarius,
Control?
Houston, go ahead.
Okay. We're ready to do the yaw,
Roger,
Joe.
would you let us know when do you want us to yaw another 90 degrees right?
Mm-hmm. He's calling it. We're there now. Go ahead.
Will do, Jim. Stand by one.
Flight, did you say we're there?
Yes, we're there now. Go ahead.
Okay, Jim, we're ready now to yaw another 90 degrees to the right.
Roger.
Flight network.
Good.
We're experiencing some uplink noises from Madrid as well as downlink noises. We would like to have them break their lock on the limb and try to reacquire. It should not impact anything other than we won't have voice uplink for a few minutes.
Okay, Inco, would the crew hear noise?
Yeah, they'll hear the noise.
Capcom, tell them, Capcom flight, let them know we're going to break lock a minute to try to improve our uplink. We're seeing some fluctuation.
Raj, do I understand they want him to
He doesn't have to do anything, right?
That's
He
affirmative.
doesn't have to do anything. He'll just hear some noise when we break lock, and we're trying to improve our situation.
Okay, fine.
Aquarius, Houston. We are going to try to improve the comm and telemetry by temporarily breaking lock and reacquiring. You may hear some noise in your headset.
Okay, could be any more noise we're getting now.
Right.
This is Apollo Control. It's 66 hours, 37 minutes. Flight Director Glenn Lunny is still in the control center. We will notify newsmen on this line when he leaves for the MSC auditorium. Apollo 13 now is 197,424 nautical miles from Earth. Its velocity is 2,953 feet per second.
Aquarius, Houston, go ahead.
Okay, now there's no noise. Keep it loud.
Jim, I didn't copy that. Your comm is pretty good, though. How's it with us?
Flight from control.
Good.
He started his yaw right.
Okay.
Houston, do you want to reconfigure the down voice back up again?
Aquarius, Houston, I don't think so at this time. Our voice is good now. How's yours?
Flight info. Yeah, we can go to down voice back up here.
You do want to go, even while we're maneuvering?
Okay, why don't we stay where we are for a few
We can wait until I get to the attitude.
Why don't you get to the attitude and then check your DB?
Right.
Just like a comm man.
Like you do DB next. Okay, then we can do the
sure would like to look at some plotted profiles. May I do that anyway?
Certainly, I'll just put them up.
Okay. Okay, I'd like to look at them. I haven't seen enough of that stuff yet. I've been getting the conclusions, but I haven't been seeing enough of the data.
Flight recovered.
Dawn's flight.
Just recovered. Just give you a quick status of what we're up to. We're moving the carrier to the west, Mid-Pacific line, to cover this offing of this fast return, adding 118 hours down back time.
Okay. My personal opinion at this time is we'll probably come back at 142, but that really remains to be seen.
All right, 142 is well covered.
That's fine. Thank you. That's what I wanted to hear. Jerry, do you want to round your team up and go through the...
I want to get all the Gulfstream guys on here in the next 10 minutes, so...
And I want all you other guys who have been here all night to stand by and hear all this, and then I want to see you all afterwards.
Okay, I'll give you about 5 minutes, and then I want to see if all of us go guys report together.
58, we've got H2O plastic for you.
Bob, can you hold off on this one? Glenn wants to look at it first, and I'm not thinking this is right this minute. And we'll have him either go back there and go through all of the changes with you guys. I'll have him start that here. Okay. He's out of the room right now. He's the one that's looking at the thing. I will be, but later.
Okay.
Okay, all flight controllers, give me an amber light. Sure you with me. Actual flight. Flight info. Go info. You call? Yeah, I want you to stand by here, Hudson. Okay, stand by just a second. Okay, I think we're about ready to let some of these people that have been here all night get out of here. But before we do that, I want to talk over with the guys coming on what we've got to do to, on the next 6 to 8 hours, quickly to make sure that we're ready for this burn tonight, whatever we decide to do. Now, okay, let's first talk about what we talked about in the way of maneuvers. We've talked about a super fast return that would require a burn at PT plus 1.5 hours, approximately. It'll get us back at 118. In order to do that, we've got to dump the service module. And we're going to push the bit. In order to do that, we would push the bit up to somewhere around 300 feet per second remaining. From what I've heard, it sounds to me like that's probably not the were made at this time, based on several things. One is the fact that this service module doesn't appear to be real good, and also we're more sensitive to misalignments over a long burn like that. In making the 142-hour return, we can stay in probably a pretty good misalignment and do well within Pennsylvania Pittsburgh capability. The fast return, I'm calling the 142-hour return time now, which is a PC plus 2 burn of, I understand, about 850 feet a second. Is a pretty comfortable thing to do, just with respect to good recovery, possibly out in the Pacific. So I think the way we're probably leaning toward now is not the super fast return, but the PC plus 2 maneuver, where we get back to 142 to the NTF. Now, that's not cast in concrete yet, but I think we ought to, most of us in the room, will start thinking about at least in no time, and making sure that we can do that and see what kind of power profiles we're going to have to get on the way back to get us to touchdown. Let's talk a little bit about the burn, no matter how we do it, whether we did a 1.5 or whether we do we're talking about a PC plus 1.5 or a PC plus 2. We've got a problem in either A, realigning the platform, or B, verifying that we've got an alignment that's acceptable at the present time to go ahead and do a maneuver. Smart money says that we should be able to get a P-52 with the A13 after we go into the shadow of the moon. If not, we should be able to do the 142-hour return burn, that is approximately 850 foot per second burn, with our present alignment. Now, I think one of the things we ought to get to work on right away is some way to verify that we do have an alignment at the present time acceptable to do that maneuver. I personally think, and this is my own feeling, so I don't want to turn everybody else off on this, I don't think we should really think about some alternate method to align the LEM platform prior to PC2. I think we ought to the way we ought to go is try to do it with either a good P-52 in the shade or with our present alignment.
Can I say something, Jeff? One of the best arguments for the present alignment being adequate is the results so far of the post-burn tracking. Doppler all fit. Prado, you're going to take a batch at 67. When are you going to have the HPC, etc.?
I'll get you an estimate on that flight. Something I wanted to point out in that area, though, while they're working these
I don't want to confuse the issue. My only point of that was that the burn results should indicate that we have a good alignment. Right? Do you have more to add to that?
Yeah, what I want to say is that the burn results also, we've worked out a plan where we can conserve even more power. Just when you get around to it, it has to do with the power amps. If we have a good burn well, we can delete the power amps. We've been getting two-way, sometimes three-way data on the Omnis only with the just the transponder feeding it.
Okay. I wanted to say that for the record, Joe, because maybe some people didn't know why we have had conflict so far in the line.
Flight network. Go. We've got a CP problem. We'd like to recycle CPs and come back with only one for a period of about 2 minutes.
Okay, we're going to leave data for about a minute.
About 2 minutes.
Okay. Everybody, raise your hand if you've got a problem with doing that. Okay, go ahead. Okay, and James Turner's been doing some work over in the trainers with the different star visibility problems that we've talked about, and with some of the attitude control stuff and some of the manual throttle, or not manual throttle, but some of the throttle up characteristics, and I assume that's without the service module on. That's the only thing you can look at, in case you wanted to do that. Yes, P-52s are with the service module on doing the same, but the throttle is one I heard later, and that's trying to see if there's any problem with the throttle up with the service module on. I really don't think we're going to know a whole lot more, at least about Apollo 13's capability of seeing stars until we get into the shade. I assume that Jim has not tried all the options yet of seeing stars out in the sun, like that is, looking to see if thing directly into the sun, as John Wonder was talking about tonight. See if we could shade the optics very much to see it, or to see if we could also see the stars out of the moon. But I don't think we're going to have time to do that anytime prior to going into space. So it sounds to me like that what we're going to have to do is to get the P-52 in, or we're going to have to go in to a Frederick alignment. Does anybody have anything they want to bring up there, either in a technical nature or in a method of philosophy that you might want to talk about? Something else different from that.
Oh, flight retro. The sensitivity I gave you on that burn was not as bad as we thought. It's more like a 90 feet per second for a fixed missile line with a degree. Okay. If you did the big one with the service module off. Yeah, okay. But that's pretty big mid-course attack.
Jerry, relative to the P-52, Jim has asked that we figure out a minimum power procedure to move the rendezvous radar out of the way, and you guys are supposed to have that here.
Very firm. It's coming to me very shortly.
Because you got to approximate the...
Okay, to get the AOC in the proper position.
Flight FAL.
Bill?
There was a recommendation that if that P-52 in the dark side didn't, we weren't able to do it, that we'd do a P-52 on it first in the sun. Is that?
From what I can tell,
we'll have the data on it.
Uncertainty, at least right now. Now, maybe somebody can change it, but there's enough uncertainty in that procedure that we'd probably be better off with the alignment that we've got right now. Now, that doesn't mean we should drop that off. Everybody should continue to look at that and run that one out the ground. But I don't think we want to do that right now based on what happens.
Flight. Okay, Houston, Aquarius, we're dispatching in the new attitude.
Okay, Bill Guyton.
What about the third
Aquarius, Houston, roger that, and your comm is good.
I think we probably should rule that out as a possibility right now, Ken, prior to the burn. After the burn, and to do the mid-course, subsequent mid-courses, I think we've got time to talk about doing that. That involves quite a long procedure, I understand. It involves taking the descent bats off. Or you could do it with a battery. But I'm talking about assuming that you wanted to do it with LEM power. Okay, heard here to go. Have you seriously considered doing that prior to PC+2? I haven't heard anybody suggesting that, seriously.
Well, I guess it really depends on what they get into with P-52.
Okay,
Here, let me see what I mean. If you had them in burn attitude, for example, these guys may be able to tell you a shaft and a trunnion and a star, and you could jack it up to the shaft and trunnion and set the star.
That's affirmative flight, and
this is something fairly simple that you could do as a check.
Okay, the check is one thing, but I think Ken's talking about using his alignment technique.
Yes, that was the other technique that would require.
Another part of his question.
We got about how much shade time here? 40 minutes?
Yes.
Once again here, I have the feeling we'd be better off if we can't get the AOC alignment, maybe to use that procedure to check the alignment, but not to try to realign it. That's not based on any science, that's not feeling on it. But I think we ought to continue to run that technique to ground primarily prior to the burn to check the attitude as opposed to realigning.
Looks like we have.
It looks like we're going to have to get time to try to get a good AOC alignment there, that you may be setting them up pretty close to the end of darkness anyway to get into this other thing. You can probably get about half done.
Right now we're showing approximately 30 minutes of shadow time to watch the 52. Should be
before LOS.
Flight from control. On that, we looked at
Go ahead, control.
Okay, on that we looked ahead at the RCS, and it looks like if we had to do two P-52s, we'd be, and it's pretty early to tell, but it looks like about 12% margin at LEM jettison. And if we had to do three, we'd be negative margin.
Okay. Okay, stand by one. It's a point I thought of and now I forgot it. Well, I can't remember what it was right now. Let's go ahead and go a little further. assuming that we make the PC plus 2 burn at 100 or for a return time of 142 hours, how do we stand, and what is the latest situation with the limb consumables? Let's talk about power and water first, tell me.
Okay,
based
Flight.
on 142 hour return time.
Projecting a power down to about 17 amps. The water is going to last till about 155 hours GET. And we're working right now on the latest GPS. I'll have some more on that in a few minutes.
That doesn't assume using any cliff water, does it? That's just
Negative. That's strictly Glen water.
Yeah, Flight, tell me.
Go ahead.
Now, you understand you can't use that cliff water in the LIM ECS loop.
No, I don't.
There's no way to get that water in the LIM ECS loop.
When did that occur? There's been a faction of people off looking at that said it was possible.
That's not what engineering said. They said you could do it.
Okay, we'll check it.
I think there's a bunch of people already checking it. Marla?
At 17 amps, what's the water rate, pounds per hour? Usage?
It's 2.68 pounds an hour.
Okay.
In fact, let me mention one other thing that I've heard since I've been in here this morning is that there may be even a way we can get some command module water in there. That in the ground too. With a long hose, doing dump hose or something. So that's two things you probably ought to make sure you're aware of, Bob. Okay, the EPS profile you say you're working on a new set based on 17 amps?
Yes.
Okay, can you tell me what that assumes after PC plus 2? What all are you powering down? Having to get the pings and the whole bit?
That's right, everything. That's the minimum power down.
17 amps. Okay,
Flight telling you.
The ascent water, or not the ascent, but the water situation you mentioned out to 155 hours assumes a power down after PC plus 2. Right?
That's affirmed.
And 2 power-ups, right?
Yes, yes, the 2 mid-courses are included in that.
Okay, Dick.
Okay, now we've got to understand the CO2 scrubbing problem too, that we can't get it all done with the LIM, so we're going to have to do something with the CSM. Now, are you guys working that problem now?
That's affirmed. We have a procedure now where we can use the CSM cartridge.
Okay. So we'll be interested in talking to you. I'll talk to you about that later. Let me do that right now. Okay, everybody stand by this minute. Okay. Okay, I'm going back over here and checking my notes, and just stand by me. Control flight.
Go flight.
Okay, now, we're doing this 90-degree yaw every hour.
Every hour, that's right.
PCC type thing.
Right.
Did somebody else looking forward now to the point of doing that in a different method, something we can spin up before, or something before we power everything down?
That's a firm. We've already, what we're looking at after the burn is really still somewhat of a manual way of doing it, but I suppose it's a little better.
Yeah, you got. You just spin it and let it go, and if you wobble
that's
and
a firm.
rotate,
that's a firm. Yeah, we're just going to put a rate in it and let it go. And we have a procedure for that plane.
Okay, it comes. The major issues that I think we've covered. There's of course, a lot of other minor stuff. I think we ought to. I want everybody right now, at least, to lean toward this 142 hours of turn time. And I'd like to, in detail, tell me when you can go over the consumables profile for that situation, both the EPS and the water. We got some other little problems going on that I think we got well in hand. This Aspen 02 thing, I understand, is a explainable problem with the South Creek light. In that you've got a leaky valve that is feeding back into it.
That's right.
No problem, right?
Right.
Span flight, are you on?
Flight span, that's affirmative, we question.
Okay, Larry, as soon as we get Chris and Sig in here, and Deep Shorty here, and I haven't seen Jim McGirt yet, but I think it's not going to be too long before these people are all back in here, and I think that's pretty well got all of the ifs and ands here, and I think that's got a way I think we ought to go, and I'm going to try to present that all to him so we can come to a decision. It's very important that if you've got any input from the 45 troops on either the total subject, specifically there's some things that we need out of you guys on the heat shield aspect of jumping the service module.
Right.
Also anything else that any of the stand people might have. That includes any of the contractors that you're working on.
That's affirmed, yeah. They're working it not only from the heat shield, but the total thermal picture with respect to the command module, RCS, water, and everything. Now, we estimate at 70 hours we should have this all resolved.
Okay, I think prior to that, we probably should at least have draw some preliminary conclusions anyway, because we'll get together before that.
Right.
We can reserve a final decision for then, but we want to talk about it before then.
Okay, well, some of the preliminary conclusions are is that you can't do it because of the thermal problems.
That's what I heard.
Okay.
That's what I want to hear, though, and get the people available that can talk about it.
Okay, and also the other thing we're working is this IMU heater business.
Yes, that is whether we have to power the
right.
Clippers.
That's right, and we're going to have that.
I understand the preliminary leaning there is that we may not have to, is that right?
That's right.
Okay, that's a procedure that I think we ought to really stay away from until after we get the PT, plus whatever burn we do.
Well, we're trying to do that.
Okay. Anybody else in the room here have anything we need to talk about right now?
I'd like to discuss my plan. I mean, what I'm going to do here is first I'm going to get one for PC plus 2, a reasonable return at 142 at 2 hours after. Then I'm going to work one up for 3 hours after. And have both of them standing by.
Okay.
The actual Glen one is this.
Flight fighter.
Go ahead.
The only thing I'd like to add here is that along with our maneuver determination and the radar when we come out from doing this maneuver, we're going to try and schedule some mid-course at 24 hours out from the burn instead of 12. That'll be our first opportunity, which would allow us to stay powered down a little bit longer.
What TP is that?
It'd be about 104 hours.
Yeah.
104 hours, and after the burn would be our first mid-course, assuming that we do this thing, you know, it comes out reasonable.
Yeah, and that's all just depend on how good the burn is.
Roger, and again, on that same point, if the burn comes out reasonable, why we can take those power amps as far as the tracking is concerned, take them down. We'll go ahead and track without them.
Yeah, that's one thing that hasn't been said here. This whole comm situation ought to improve when the IU impacts. Half our trouble more than that has been that other frequency, right?
Yeah, that shows it's 77 hours.
Days, 67 hours you were taking it back. Have you got a vessel yet?
No, I have a new estimate of 6830 for you.
Why is that?
Well, it had to do again with the S4B. They had some data that could perhaps have been on the S4B, and they wanted to delete it. I can get you a preliminary estimate, though, that'll hang pretty tight to what we were...
I'd like to see that as quickly as you can get it.
Flight info. So, just to be sure you understand this F4B and LEM comm thing here, it's only going to help us during the handovers. We won't have to turn the transponder off for the handover. That's all it's going to...
Yeah, I understood that. Everything was linked. I did. Okay, Capcom flight. Just a digest.
Okay.
Okay, say all this on the loop. Okay. Very little.
Let's see, we have the ranging turned off at this time, and based on Fido's comments, I assume he's going to be happy keeping the ranging off for PC plus 2.
Yes.
Let's see, if we power up the CSM prior to PC plus 2, is there any possibility or consideration given to charging bad A, CSM bad A?
Okay, right now there's not any consideration given to doing that stuff.
Okay.
So let's don't skip that one into the loop.
Okay. That's all I had, Jim.
Okay. Okay, everybody, that's about all I've got for you. I think it'd be good. Glenn wants to talk to his guys, I think, before they get out of here. But we probably ought to try to get this room as quickly as we can, kind of back to some sort of normal configuration. So don't all you guys that have been here all night just to stay around to hold our hands. There's not much we can do here for a few hours anyway, so get to sleep and come back.
This is Apollo Control. It's 67 hours, 23 minutes. Flight Director Glenn Lenny is still in the Mission Control Center.
Recovery flight.
Considerable discussion and
Go ahead, Mike.
meetings on the floor here
Our recovery
since
posture at 142.
his shift changed. He and Flight Director Jerry
that's
Griffin.
affirmative. We will, if you'll pull up channel 49.
Director Flight Crew Operations, Deke Slayton, the Apollo Mission Director Chet Lee, the Apollo Program Director Rocco Petrone, and other
she can make it in,
management officials have been holding some discussions.
Weather is good there.
We have no estimate on when Mr. Lunny
kind of moved out of the picture
will be able to get away at this time.
Let me give you the
We will attempt to summarize for you some of the discussions that have been going on here. We're still leaning toward the burn at Paracynthian plus 2 hours.
10 miles visibility.
That's the descent propulsion system burn at 79 hours, 27 minutes,
our current
850 feet per second.
Okay.
Or landing at 17.9.
As an option, a number of people are taking a look at what is being termed a super fast return. Would require a larger burn at Paracynthian plus an hour and a half.
Yeah, right there.
This would bring us
that would be the landing point
to a splash time of 118 hours versus 142 hours. However, to accomplish this, we would have to jettison the service module.
Okay, thank you, Kevin.
Preliminary data indicates that we may have a thermal problem on the way back without the service module. There's also some other aspects that need to be looked into. This option is being held open and is being worked and will be for the next several hours. However, as I say, all of the officials here are still leaning toward the Paracynthian plus 2 hour burn with a 142 hour return. In connection with the superfast return, astronaut Gene Cernan has been doing some work in the trainer on star visibility problems, manual reaction control, manual throttle work, and this option will be kept open for some time. Another problem with the superfast return is that we can't stand as much misalignment with the inertial platform on a long burn as we can on the 142-hour return. We, at the present time, would feel more comfortable with the 142-hour return. We expect to be able to get a program 52 or a platform align. That's the program for aligning the inertial platform with the alignment optical telescope in the lunar module after the spacecraft arrives in the shadow of the moon. There's a 30-minute period where we can look at the spacecraft through telemetry and watch how the alignment goes prior to the time that we lose signal. We're 9 hours, 41 minutes away from LOS now, but there is a half-hour period when the spacecraft will be in the shadow of the moon and an alignment can be attempted.
Gentlemen, could I ask the
if
flight team guys
we're unable to align,
convene with me?
We think we can do the burn with the present alignment. The results so far of tracking since the last descent propulsion system burn indicates that the present alignment is good.
Okay, let's go down to the VIP room in the second floor and bring your data, please. Okay? And before you leave the building, come back up here and tag up one time with your comrade, because I'll come back.
We're looking at a plan now that after the burn, where we would power down to 17 amps. That's a minimum power down. With that power down, we have enough water to last to 155 hours
ground elapsed time. In addition to that, we would have the water from the portable life support systems.
Off now. Again, if we don't
The
need
water
voice,
use rate at the 17 amp
go to voice loop
power
here
usage
and
would be 2.68 pounds per hour.
Okay, we should be able to talk to him now.
These projections also include 2 power-ups for mid-course corrections on the way home.
Okay, how does he hear us in that?
And procedure has been worked out to use the command module lithium hydroxide cartridge for CO2 removal.
Breaker and go to the mode function switch to down voice backup.
And we are presently yawing manually 90 degrees every hour for passive thermal control. After the burn, we may put a rate into the spacecraft, a roll rate into the spacecraft, and let it go to attempt to set up some type of passive thermal control that doesn't require complete manual operation.
Take the mode function switch to down voice backup. It should make no difference from
the flight dynamics officer reports that if the burn is a reasonable one, that they would schedule a mid-course probably at 24 hours out instead of 12 hours.
That if we have
that would be a elapsed time of 104 hours.
That's right.
Stand by, please.
And he's due for another 90 yaw in about 8 minutes.
We expect communications to improve a little bit after S4B impact on the lunar surface.
27 minutes, flight. That'll be at 68,
S4B frequency is giving us a little trouble with this communications.
So before we do that 90 yaw, do you think
after the impact, we will not have to turn the transponder in the spacecraft off during handovers between tracking stations.
We think it's going to be okay when he gets to the.
That's the situation as it stands now. We'll keep you advised as to Flight Director Lunny's availability. This is Mission Control, Houston.
I have down that he started the last yaw maneuver at 66:34, and he told him to do it every hour. I'm sure it's not that critical, but.
Control flight, you copying that?
Say again, flight.
Are you copying that?
Negative.
The Capcom says that he recorded here that we had him yaw at 66:34 last time. I'm not sure it's in Glenn's notes.
That's the time I show too. 66:33. We did yaw right. And I copied. Okay, I'm sorry I gave you. Okay, that's completion time. 67:02.
Okay, 67:02 is the completion time. Is that where you start the hour from?
Right. In other words, it took him 29 minutes to do that. Okay?
Okay. Captain,
is that fair enough?
67:02 is the completion time. That's where he starts his hour from.
Okay, real fine.
Took about 29 minutes to get around.
Good deal. Okay.
So we'll go ahead and...
My mistake.
Yeah, let me verify. I think that's what we're doing. Let me verify that.
Okay, we can go ahead and pull a power amp circuit breaker and mode function switch to down voice backup.
Roger that.
Aquarius, Houston, over.
Go ahead, Houston.
Okay, Jim, in order to save an amp or two of power here, we'd like you to go to the down voice backup comm configuration, which is pulling the power amp circuit breaker and going to down voice backup. If we get into a comm problem, all you have to do is reverse that configuration and it should be good again. Over.
Flight from control.
Go.
Okay, I'll verify that. That's definitely the way we've been doing it. Okay. And also, can I verify?
Okay, we'll go to down voice back up and pull the power amp circuit breaker.
Can I verify that?
And if we get in trouble, we'll come back again.
We asked them
okay, real fine, and we estimate the next yaw maneuver should start at about 68:02.
Annunciator docking component circuit breaker under lighting on.
Okay, can you give me that in minutes?
16. Did we do that?
I sure can. That's going to be in 29 minutes from now.
We talked about it internally. I don't know whether we passed it up to him or not.
Yeah, I don't. That's the point.
Okay,
I know we talked about it earlier, but
I'll just a second. What did we ask him to do that for?
That brought back his warning lights on his disky.
Yep, flight right now, nobody can see anything out of the computer, so we had him power up just the panel that would allow him to So the circuit breaker was allowing me to see its emergency warning light on the distance down. And it was very low.
We did ask you to do that ourselves.
It went up to the cruise?
Yes. Fine, good.
Yeah, good signal. Okay, Houston, we're down ways back up, and the power amplifier is full.
Jim, Houston, roger that. You are readable through the noise. How are we? Over.
You are loud and clear.
Very good.
Hey, flight retro. Go retro. All right.
This is Apollo Control at 67 hours, 38 minutes. President Nixon talked with NASA Administrator Dr. Thomas O. Paine at 7:45 a.m. Central Standard Time today. Dr. Paine, who arrived in Houston by NASA aircraft at 6:40 a.m. Central Standard Time from Washington, was in mission control and gave the President an update on the Apollo 13 mission. Mission control is in direct touch with the White House. We'll continue to stand by now for live air-ground transmissions. Since
they believe the crew to be safe, and the chances of their safe return are excellent. It's a matter of speculation what caused the failure of the fuel cells in the command module, thereby
We'll let him keep going.
An explosion may have occurred, or it is also possible that the Apollo service module, where the fuel cells are located, was hit by...
Okay, let's go ahead and throw it to me.
That is a review of what
Yeah, go ahead and throw it to me now,
My
Larry.
warmest thanks for your timely and generous offer of assistance of French ships in recovering the crew of Apollo 13. Should circumstances require it, we shall be in touch with you regarding the necessary arrangements. End of quote.
This is Brian Duff, the Public Affairs Officer, beginning our press conference in Houston. Glenn Lunny,
You ready?
Flight Director, will be on task.
Change of shift briefing. We have with us this morning Major General David Jones, the DoD Manager of Manned Spaceflight Recovery, and Glenn Lunny, the Flight Director for the shift which just ended. And I'd like to ask Glenn to introduce the men he brought with him.
On my left, your right, Hal Loden, who is the what we call the control officer. He worries about the propulsion systems in the lunar module. Tom Weichel is the retrofire officer, excuse me, whose job it is to assess all the options that we have on returning to the Earth and to make recommendations as to which one to use. Merlin Merritt is the what is called in the control center the TELMU. He's concerned with the electrical systems, the environmental systems in the lunar module. And Clint Burton on the end is the ECOM, who's concerned with those same systems, that is the electrical, the environmental in the command service module.
I think we should proceed in the order which seems most logical, whether you would start with General Jones or you, Glenn.
Yes. I think I probably should come last because we're really responding, and I think that as the various options are described to you, we can say that we are well prepared in all of these options as far as aircraft availability and in most areas as far as ship availability. We've been in touch with forces worldwide, and as you just heard, we've had offered some help.
This is the general in charge of recovery operations explaining contingency planning.
The story I'm getting is that he did not leave a area have offered their support. But as far as aircraft is concerned and ships are concerned, I think we're equipped and ready for most any of the options that NASA exercises.
Right.
I think that's all right now.
Well, if you want to, I'll start with a summary of the shift, and then we can go to questions and answers, and the man on my left can perhaps help more than I can with some of the detailed questions you may have in the various areas. Let me start off by saying that we, in the business, have probably had the longest night we've had in the space program in a while. My team came on duty last night. We were supposed to come on about 10 p.m. and we got to the control center as usual about an hour ahead of time, and some of the men were already there, and the rest of us, I for example, I was in the back room going through the staff support rooms, checking on the status of everything, and we just finished the television show when we found we had a problem. Now, I wasn't on the console, nor did I hear the ground when we exactly had the problem. And let me say that since that time, my team has been primarily concerned with not what happened back there, but what it is we were going to do about it. I'll tell you what I know about what happened, and I probably will only be able to take that so far for you. I'm sure that when we've had time to construct exactly what happened, we'll be able to tell you in more detail what it is we think caused the problem.
This is
At
Flight
about
Director Glenn Lunny.
55 hours and 54 minutes, tank 2, cryogenic oxygen, was fine. Within less than 1 minute, the pressure in that tank had gone to 0. At the same time, fuel cell 3, which was on main bus B, and we have split the buses on this flight. Fuel cell 3 was the only fuel cell in main bus B. Fuel cell 3 went down, and the main bus B went down. We had some restarts on the computer, and they were probably due to the main bus problems. The situation was one then where we had a relatively uncertain situation in that with some of the electrical systems down like that, it's sometimes difficult to determine whether you have instrumentation problems or whether you're having a real problem. However, in this particular case, during the whole course of the action, I think everybody in the control center felt that we had a real problem rather than any kind of an instrumentation problem. The crew reported a loud bang at the time that correlates with the tank pressure going to 0. And they also reported some venting. They could see some things out the left window, and they were getting some rates in the vehicle. Now, the problem with the control system, or the situation with the control system, is that it is split. Some of the thrusters are on main bus A, and some of them are on main bus B. And, of course, losing main bus B, we had some amount of difficulty with control, as you probably recall hearing. One of the other things that happened, which substantiate that something real physical happened, was that the propellant isolation valves on Quad Charlie, we think, closed, which has been known to happen in the past, started back on Apollo 9 when we did a separation from the Saturn. We noticed that the valves closed. We reopened them with no trouble, but that's another indication that something happened. Now, the area where the cryogenic tanks and the fuel cells are is kind of behind the commander's seat on the left-hand side and down a little bit below what you would call 3 o'clock, perhaps at about 4 o'clock. And the venting and the particles that were being seen out the number 1 window, which again is on that side. So we had pretty concrete evidence that something had happened back in the service module. I don't think anybody fully understands it, but it appeared that something gave way, causing a problem with the fuel cell. Something in the cryogenic tanking gave way, causing then a problem with the fuel cell, probably a physical impact of some kind. And we had about that kind of situation on our hands. Now, Gene Kranz's team was on at the time, and their concern was to, without taking any steps that would jeopardize or compromise the condition of the vehicle, to stabilize the situation as best we could, so that they tried a number of configurations with the jets in order to have proper attitude control. Plus, we were continuing to monitor and go over the electrical system in the hopes of finding something in the instrumentation, but also with the end in mind to figure out what to do about the configuration of the electrical system. Shortly after that time, it became apparent that cryogenic tank with the oxygen in it, there are 2 tanks, 2 with oxygen, 2 with hydrogen. It was apparent that the pressure in the second tank, that is tank number 1, was going down. And this started about the time of the first tank going to 0, but it came down at a very, very slow rate. As a matter of fact, it worked for about 3 hours. We had pressure in the tank enough to feed and make a fuel cell operate for about 3 hours. While the tank was going down, while the pressure in the tank was going down, we performed a number of things in order to attempt to save that tank. The cryogenic oxygen is brought together in pipes and then fed to the fuel cells. The plumbing of the fuel cells is such that if you had a bad leak in one of them, that is a line open or something, it's possible it would operate in such a fashion that all the oxygen would go find that leak and go on out. At that time, then, we shut off what we call a reactant valves, which are the hydrogen and oxygen to a given fuel cell, in an attempt to stop flow to a position in the plumbing where a leak might be and where all the oxygen might have been going. That actually was to no avail. We did that in each cell, one by one, picking the worst cell first, and at no time did that change the leak rate. And of course, once we close the reactant valves, we very quickly lose the fuel cell and it is no longer available. We were reluctant to take that step, but it was our last-ditch attempt to isolate a leak. It did not work. At that time, we moved two of the pilots into the lunar module in order to start preparing the vehicle in what I guess we would call a lifeboat mode. We discussed this amongst ourselves in the past, how we would use the lunar module to come on back. Let me say one thing about the trajectory at this time. Of all the times on the way out to the moon, this is probably the most difficult time for a problem like this to occur, because the delta V, or the propulsive maneuver that would be required to come back to Earth directly without going around the moon, had become excessively large. For example, we could have come back with a 6,000 foot per second burn out of the service module. We don't have anywhere near that out of the LEM. But in order to do that, we would have had to dump the lunar module. We would not have been able to get that kind of delta V with the lunar module attached. So that quickly became out of the question with the developing problem we had with the cryogenic oxygen. Quickly, it became clear to us after we had time to review it that the course of action was to retain the lunar module and to swing on around the moon and to prepare to do a maneuver which would in effect shorten the return time back to the Earth. We got acquisition, as I say, we moved, two of the pilots moved into the lunar module at about 57 hours and a half, and about 25 minutes later we got acquisition on the LEM, which meant that the telemetry system had been turned on. The first entry to the LEM was primarily one of just making it livable, the batteries, the power, the glycol loop flowing, etc. At this time, it was obvious that the command module cryogenics were effectively lost because we had done all that we could. We wanted to retain an alignment on board the lunar module because we knew we had to do a maneuver coming up, and because it is difficult to do alignments with the telescope while you're docked to the CSM. In order to do that, we put a battery on the command service module buses in order to supply some more power. We did this when we figured the fuel cell had just about breathed its last oxygen. We put the battery on and we used it for about 20 minutes, perhaps 30 minutes, while we were performing an alignment, which then gave the lunar module a good attitude reference system. The attitude reference system is mandatory to do a proper burn. It's the system that points the vehicle and the engine, and it's the system that then controls the burn.
Tell me, Flake.
At about 58:40, as I recall, 58 hours and 40 minutes, we turned the command module power down completely and took the battery off the bus. At the very end, prior to putting battery A on the bus, we had used it previously. We charged battery A for a short period of time in the hopes of getting a little more current in. The three entry batteries in the command module, of course, will be the batteries they will use for entry, we'll use for entry. And I should say that they're in fine shape. The command module, which is the portion of the vehicle which will re-enter, is, as near as we can tell, in fine shape. We have electrical power, we have a coolant system, we have a command module RCS system, two of them actually, and all the other systems are still in fine shape. We powered the guidance and navigation system down, of course, but we can power that back up prior to entry. At about this time, then, we had to start configuring the lunar module in a fashion that would allow us to fly. We were looking at the fact that we knew we had to make a maneuver at about 79 and a half hours, which at that time was about, 19 hours away, and we knew we had to do that on the other side of the moon, so we started to talk about how best to configure the lunar module to get to that point. We did not want to lose the alignment.
This is Flight Director Glenn Lunny explaining some of the problems over the night and the decisions being made.
And at the other hand, we didn't want to spend too much power because we are fairly limited in the power that we can supply, and the biggest users in the lunar module are the LGC, the computer, and the platform. So we were concerned with that. However, in my mind, we had essentially a safety problem in wanting to retain the platform. We wanted to do as accurate a burn as possible, so that in my mind there was not too much question about turning the platform down as long as we could get enough out of the consumables to safely conduct the burn and use the lunar module and as a lifeboat on the way back. Merlin Merritt, who's watching these systems in the lunar module, was very concerned about the status of our consumables at this time, because when we first powered up the lunar module with the coolant system, larger than normal amount of water was being required to cool the vehicle because it had gotten warm, and the initial flow was taking some time to establish an equilibrium, and we at first were looking at fairly high water usage rates. These subsequently slowed down and they continued to get better, and as time went by it became more and more clear that we wanted to leave the computer and the platform up, and that we would have the consumables to do the job all the way home, and I'll talk about those towards the end. At about 60 plus 23, we informed the crew that we wanted to perform a free return maneuver very shortly. Now, the logic behind this was that we had the situation which I've described in the lunar module, and we had about 19 hours to go to the burn to bring us back home. At that time, without any further maneuver, we would not have been returning to the vicinity of the Earth. So we felt it was wise to spend the time and the consumables at that time to do a small burn. It was about 38 or 40 feet a second, which put us essentially on a free return path back to the Earth. This loops around the moon. We're still not sure of exactly what altitude we'll go by the moon. We targeted for about 137. It'll probably be higher than that, although that's still being tracked and worked upon, and I'm sure you'll hear that number in the course of the day. With this decision, we had to go through the checklist to prepare the lunar module for the burn, and we did it not quite as formally, but perhaps as completely as they do at the Cape when they're preparing a vehicle for launch. Fred went through each page, we went down each page, had everybody in the control center agree that we either had to do what was on the page or could delete some of the items. We were interested in deleting what we could, of course, because some of the things used power, and in the situation we were in, it seemed prudent in a number of cases not to use that power for that particular function. We did the burn. The numbers are all available up here, and the burn went fine. The guidance system performed just fine, and the tracking, the Doppler tracking after the burn has all confirmed that the burn was nominal as we had planned, which is another good indicator that the platform or the reference in the lunar module is in good shape. I'll review the consumables at the end of this. Let me tell you what is coming up. At the present time, we're in what you might call a modified passive thermal control mode, where usually on the way to the moon, we're rolling the vehicle, and it's standing up. If you look from the Earth to the moon, it's standing up and it's rolling to get a equal temperature distribution from the sun. In this case, what we're doing, since we don't have a good control mode to do that from the lunar module, we're just cycling the vehicle about every hour through 90 degrees so as to equally heat and cool both vehicles, both the command module and the lunar module. That's going very well, and it takes not too much attention on the pilot's part, and we can look at that data on the ground and be sure as we go along that the attitude control system's doing the job. We have had some poorer than usual comm in the last few hours. That's because we've taken a power amplifier, which is essentially just a booster for the comm, and taken it offline, and we've got comm equivalent to what we used to have over some of the ships in the Mercury program. It's saving us 2.5 amps, and at the present time, people are being as stingy as possible about how many amperes or how much current we're using out of the LEM batteries. Looking ahead a little bit, we're expecting to wake up Fred at about 69 hours, and he may be up already, and the other two men are scheduled for about 6 hours sleep. We are looking to do a burn at 79 plus 30, although there's still discussion about doing a little bit early. We have considered and are still considering what the possibilities are for dropping the service module, which is a large amount of weight, in order to accomplish a faster return to Earth with the lunar module engine.
go flight.
There are a number of considerations involved in this.
It's in process now.
Not the least of which is the new thermal environment which the command module heat shield would be exposed to. Of course, it has never flown in space like this. It would have never flown in space like this without the service module on, and there is some concern about what would happen to it if we did not have the service module on there. I say again, the reason for considering dumping the service module is that you can speed up the return and perhaps, and this is really a perhaps, land a day early, but you would end up using just about most of the DIP's fuel, and you would be probably have a little bit less than we would comfortably like to have. I say that this discussion is still going on. These kind of options are still being entertained, and sometime in the next few hours I expect that we'll decide exactly how we want to do the upcoming burn, and you'll probably hear it on the air to ground at the same time I do. We will probably do something else on the way back after the burn. We'll probably turn down the guidance system on board the lunar module, since it is a fair user of power, and it also has to be cooled, which causes it to use water higher than if we were able to turn it off. The water usage is higher with the guidance system on. We will probably also consider going to a duty cycle on the communication system in order to again save power in the lunar module, and probably at some point power up the comm on some schedule as opposed to having it up all the time. Those things are in the future, and you'll be hearing more about them. To give you some idea where we stand on the LIM consumables, right now with the water that we have in the lunar module descent and ascent tanks, we can follow the profile that we have intended to follow. That is powering down the primary guidance system after the first burn, and power it up 2 more times for mid-courses, and land with still about 12 or 13 hours of water of cooling available. So that is beginning to look like we are in reasonable shape there. We are also studying some ways, possibly getting some more water into the cooling system, and we're not sure how those are going to work yet. On the batteries, we again are planning to follow a course which will end up with about 500 or so amp hours left, which is about 22%.
This is Flight Director Glenn Lunny explaining some of the problems which have occurred overnight.
It's beginning to look like a fairly comfortable margin. Of course, that is dependent upon following the power profile that we've laid out, and you'll hear people talking about a couple of amps all the way back, and the intention is to follow the profile. I don't have the O2 prediction, but that's generally better than the water in the power. The lithium hydroxide canisters, we have about 50 some hours for the 3 men with the canisters in the LIM, and we are preparing a few techniques for using the canisters and the carbon dioxide scrubbing, which is available in the command service module, and you'll hear some more talk about that on the loop, I'm sure. I think that about summarizes what I can say at first blush, and perhaps my comrades and I can help you with further questions you might have. Brian?
All right, we'll take questions if you'll wait for the mic. Let's start with Roy Neal. He's the first up.
Glenn, you've described the situation accurately in terms of hardware. How critical is this situation right now, in your opinion?
Well, I think it is as critical, perhaps probably the most critical situation we've faced so far in the manned spaceflight program in flight. We are about 70 hours from home, and we think we have the situation in control. We've projected the consumables as I've described, and we have a plan for carrying out the rest of the mission, but there's going to be no relaxation at all as far as that goes from now until splash.
The oxygen situation.
The oxygen? I didn't bring in numbers. Merlin, can you talk about
yes,
oxygen?
The oxygen situation, we're, I think, in pretty good shape.
We have about 160, or we should have enough to complete O2 requirements for a elapsed time of about 165, 170 hours elapsed.
In other words, we could fly that long with the lunar module oxygen. And I should be very careful to point out that we still have the normal command module oxygen supplies intact in the command module. Those are used for entry and post-entry work.
That last answer from Merlin Merritt.
What was the most critical single thing that had to be done last night? Was it getting that reference platform set up on the LEM before the collapse of the command and service module power?
Well, in my opinion, the most critical thing was people keeping cool and getting done what had to be done. And I think we were able to do that. I think especially the pilots remained cool throughout the whole thing, and so far we've been able to stabilize the situation, and we have every intention of keeping it that way.
I don't think he passed up any
what happens if you do run out of water before you come back in? And secondly, it is my understanding that if you went on a suit loop, you might save some oxygen or conserve somewhat. Is there any consideration of this?
If we run out of oxygen, or if we run out of water, it will get warmer in the lunar module. We'll probably have to do something about orienting the vehicle to try to cool it. Usually we try to equally heat it on all sides, but I suspect if we really ran out of any coolant water, we would go to something like that. There's plenty of drinking water in the command module, although we have to pressurize the system to use it. There's some extra drinking water in the LEM. I don't recall how much. And you asked me a second question. The cooling in the command module is just fine. We just aren't using that system at all. That's buttoned up right now. But all the cooling capability in the command module is still there. And as I said before, the command module itself is completely intact.
That was Glenn Lunny answering that.
Oh, yes. Going on the suit, but we only have two connectors in the lunar module for two pilots. And Merlin, you want to comment on
if
the
I may, yes. No, I think that's incorrect. It'd be preferable to remain in an open atmosphere. That way the usage rate is not as much as if it would if you went on a closed suit loop. Besides that, we only have the capability to maintain two crewmen in the LEM in a closed suit loop.
No, in order to do anything now in the command module, we'd have to turn some equipment on. So we just got the door open between the two vehicles and letting the command module oxygen, or the lunar module oxygen, come over now. We've sealed up the command module system. Okay.
We have a suit compressor that circulates the air, the atmosphere in the cabin through the suit loop, which does remove CO2. So.
Something last night about moving one of these hoses so it would move the carbon dioxide or something out of the command module.
Yes, we did move a LEM hose, stick it up through the tunnel area such that it would circulate O2 into the CSM.
That was to blow fresh oxygen into the CSM in order not to get a buildup of CO2 while the men were sleeping in there, one man last night.
Sensors anywhere that'll give you a chance to draw some inferences about the condition of the heat shield after that explosion or impact behind it?
I didn't hear this first part of your question.
Do you have any grounds for drawing any inferences about the condition of the heat shield after you had this explosion or impact behind it?
I don't know whether we do or not. I assume people are looking into that, but I don't know.
Glenn Lunny answered that question.
Say the life of the astronaut is complete security this time.
I'm sorry, I didn't copy all
the
that.
life of the astronaut is security, have security the life of the three crews. And the second question.
This is a correspondent from South American news service El Continental. He's asking if the astronauts are safe and secure.
They are safe in the sense that we have the situation stabilized now, we think. I think our only concern about safety is that we're now about 70 hours from home, and we have to continue to keep the situation that way and bring them on home. And you had a second part?
Second part, can you explain me what is the reason don't start the return to the home before of the go to the moon? Before of the moon, can you return the commando module to the Earth?
If you're asking if we're bringing the command module back to Earth, we're gonna fire the engine and bring both vehicles back to the vicinity of the Earth. At some time, of course, the pilots will button up in the command module and power it up for entry, and they will separate from both the service module and the lunar module. Where exactly, I can't tell you. We've had some contingency procedures for where we would do that, and I'm sure they're being looked at and reworked right now to get an exact timeline as to how we would jettison both of those parts of the current stack.
That indicates that they're doing their thing. That's
after the dips burn, as you plan it now, what sort of mid-course correction capability do you have, and what sort of mid-course corrections do you think you'll need?
Okay, of course, the burn that we're going to do is, as I said, still being discussed in the sense that we could do a reasonably average size one of about 890 feet per second, or we could do a much larger one which would use most of the fuel in the dips burn. The difference in those two burns is that for the smaller burn we would land at an elapsed time of 142 hours. For the larger burn, which runs closer to dips depletion, we would land at 118 hours. And you wanted me to relate that to?
The mid-course correction
The mid-course as well. The way we plan and target the burn, we don't expect to have any, but with the shorter burn or the longer return time, we would have a considerable amount of delta V available in the lunar module to correct it. With the larger burn and the shorter return time, we would have less than that, on the order of a couple hundred feet per second in the LEM descent propulsion stage.
We have about 3 questions in the second row. We'll pick up here.
Can you tell me where Fred Hayes slept during the night, and can you also tell us if the ground controllers ordered the 2 LEM pilots into the lunar module last night, or did they go in on their own?
Can you hear me?
To the best of my knowledge, Fred slept in the command service module, probably on the couch or maybe on the floor.
On their way in now. And I think Jim McDivitt is
I don't think that we had to order them into the LEM last night. I think as the situation was stabilizing in the command module and we knew that we had the kind of problem that we did, I think they were on their way when we finally got around to talking to them about it. As a matter of fact, we were just picking up with the procedures to activate the LEM. And I assume that they were on their way with the hatch work by the time we got to talking to them about the procedures.
When you send them up the information for that small burn last night to get back on a free return trajectory, the kind of information usually includes a weight figure for the spacecraft, and that had obviously changed because of the venting. How did you know what weight to give them, and how are you going to handle that problem on this big burn?
Well, the weight that you're talking about is the weight of the total command service module. The purpose of giving them that number is to have the guidance system do the most accurate job that it can in guiding the burn. Now, we have a number of people who try to make that number accurate to the nearest ounce, but in all truth, the guidance system can perform quite properly even if it's off by a large amount, several hundred or several thousand pounds. So whatever we assumed about the weight when we sent it up, it really wouldn't make any difference to the burn.
Is it right to assume that whichever of these TEI burns you do, you will have reacquired the spacecraft after it's passed behind the moon?
Yes, sir.
Let
me say one more thing that you just indicated. These burns will be performed after we go around the moon and on the front side. They won't be conducted in the usual TEI fashion behind the moon. They'll be conducted about 2 hours after acquisition, after they come around. Okay?
Could you tell us, please, whether there have been any private conversations with the crew and whether any are planned?
There have not been any, and I don't know of any planned.
Do you gain any flexibility from the fact that the ascent propulsion system is there? Does that enter into your contingency planning at all?
We could use it. It's a more difficult task than the burn in the descent stage. Hal, you want to talk about it anymore?
Yeah, right now with the ascent propulsion, we have a neighborhood of 720 feet per second delta V capability. But to utilize that, you're going to get rid of the descent stage, which we don't want to do. And we do have adequate margin in the dips right now, so we're not really entertaining any idea of using the APS, but the capability is there if we need it.
APS is ascent engine.
If you do the super fast return, where would the splashdown approximately be?
Tom?
What was that question again?
He wants to know where we would land if we came back at the 118-hour time.
Okay, the longitude is about 179 east. The latitude's about 1258 south.
I'd ask General Jones to comment on that, too, as to what his posture would be.
Well, in that particular case, as you will recognize, it's just a few hundred miles west of the normal landing point, and the position of the Iwo Jima is such that it can be positioned between the, well, in the center of several landing options, and at this point in time we see no problem in being able to reach the landing point ahead of landing. And by the same token, we can cover a normal with normal aircraft dispersal from Hawaii or through Pango if necessary.
Are you still contemplating a splashdown in the Atlantic area? And could you name the nations in that area that have offered to assist if necessary?
Well, I guess we're considering it, but it's probably on a pretty low priority. And I know that the recovery folks have been assessing what is there. General Jones, can you say anything about that?
Yes, we have aircraft, of course, at Ascension. We could not have a trained recovery ship in all areas of the Atlantic, but we could cover the landing with HC-130 type aircraft, and there's no reason to expect that we couldn't have fairly quick access.
This is General Davy Jones, Chief of Recovery Operations for the Manned Spacecraft Center.
Surface ship in the Atlantic, or South Atlantic.
I have two questions. First, Glenn, I'm still a little confused over why you're using the LEM for this burn as opposed to the service modules. And secondly, is there the possibility that a meteorite hit could have caused the situation that you described earlier?
By this burn, Roy, are you referring to the one coming up or the one we just did?
Coming up, right.
Well, the reason we want to do the burn with the descent engine at this stage of the mission is primarily that we don't want to do it with the service propulsion system. We've had a problem, probably a physical rupturing kind of problem in the service module area. To attempt to burn would be to deal with just an area of the vehicle that wasn't as completely clean as we normally do the service propulsion burns. What I'm trying to say is something else may be wrong in the service module area. In addition, it would take power out of the batteries, which are used for entry and landing, in order to accomplish such a burn. We can transfer a certain amount of power from the lunar module, but that lunar module, of course, is critical. We can transfer 15 amps, but 15 amps doesn't do you much good at all when you're talking about powering up a control system and the gimbal motors to do a service propulsion burn. So for both of those kind of reasons, we are going to stick to the descent burn. And you asked me a second one.
So the second question was, could the situation have been brought on by either a meteorite or micrometeorite? I don't realize that.
I don't know that. I guess it's conceivable, but I guess it's conceivable, but based on the fact that the cryo pressure, that is the pressure in the cryo tank, started to go up, reached what pressure it should have relieved at, and then went on down to zero. My personal opinion is that that probably has not occurred, but that again
which
really
we
remains
can
to be
elect to
seen.
either read to them before LOS.
On your priority list
Or
of mode of returns, where does your free return come in without
Free return is what we have right now. In other words, with no further burns, we are on a coast trajectory which, with the accuracy that we can track it, will return to the Earth and land in the Indian Ocean. Our only purpose in doing further burns now would be to improve both of our landing area and our landing return time. In other words, the free return time lands, what, about 155?
About 151.
151 GET in the Indian Ocean. And with the vehicle being well, the lunar module vehicle being well, I think we would choose to improve that situation. But not being able to do that, we have established by the burn a few hours ago the situation where we are returning to there, and we wanted to establish that.
All right, we're going to be able to take just a few more.
On the, you said you could get 15 amps out of the LEM back into the command module. Is that sufficient to power up the optics?
Yes.
Do you think then you will use the CSM optics to try to get better angles?
We are writing a procedure and having one available to use the CSM optics either through the route I described or possibly even out of an entry battery on board the command module in order to possibly check the results of the program 52, which is the alignment program that the pilots will do when they go in the shadow of the moon. However, at this time, that possibility is exactly that. We are considering using that system or that technique to check the alignment results, and we have every confidence that the alignment itself, once we get in the shadow of the moon, will work out fine in the lunar. And I should say one more thing about that 15 amps. If we really return at the end of the flight and find that we do have the electrical margin in the LEM, we can charge up the batteries in the command module, the entry batteries. One of them is down, I think, about 22 amp hours out of 45 or 50. We could charge that battery back up if we indeed found ourselves close to entry with a comfortable margin on the LEM power.
Okay, we're going to go across the front here, and Mary Bob had one, and Harry Pease, and we...
Well, at this point in time, where is your most serious concern to bring the crew safely home? Is it in what area of hardware or consumables, or in your opinion, where is the most serious area?
I guess the only way I can answer that is in the 70-some hours we have to go. I really couldn't pick anything that was more critical than anything else, but I think it's the time factor now that we're just going to have to watch and be sure that we continue to operate the vehicles in such a fashion that allows us to live and operate effectively that long in the lunar module, or else we're going to have to go in the command module and start using those batteries, which we don't want to do.
General Jones, can Iwo Jima reach the landing area, the 142-hour landing area, in time to meet them?
Okay, how about
I'm not sure. Well, yes, we can reach the areas that have been mentioned in terms of planning.
Yeah, let's look at that too.
It is now somewhat south of that, but it'll move to now is moving toward a position which is will about split the difference between the two landing areas that have been mentioned. Not the free return, not the free return area, but the areas in mid-Pacific.
I'm speaking of the one with a landing at 142 hours GET, which is something like 600 miles south of Samoa, as I've plotted the coordinates.
Yes, it'll be able to reach that.
All right, Louis Alexander in the second row has been waiting.
Glenn, how fatigued are the astronauts, and how much rest are they likely to get?
Well, I guess you can tell as well as I from the sound of their voice. I think they've had a long day. This actually started to happen at about the end of their normally planned day yesterday or last night. And as everyone can tell, we've been working at a fairly busy pace since that time. We do have some sleep time or rest time scheduled for them, And I think they'll take advantage of that and continue to perform. I'm sure they'll be glad when the next burn, the one at 79.5 hours, is behind them, because that'll give them a little more opportunity to relax. And we'll just see how they sound as we go along, Louis.
This is going to have to be the last one that's done it. This has been a very long shift for these men. Zach, you have something, and then we can...
But Glenn, when do you have to exercise these options? How much more time do you have to mull over all the problems and decide one way or another what you're going to do?
As you would expect, and I'm sure you who have covered the flight know, we'd like to be sure that we've thought out all options as long as possible. But I would suspect that within several hours of the planned burn, we will have to make up our minds what kind of a burn we want to do, and then concentrate on that. As a matter of fact, a number of times last night, we had a number of problems, but at some point you have to stop considering all the options and stick to getting the one thing that has the highest priority, getting that done, like securing the lunar module and getting it ready to take care of the pilots. And I think we're going to decide several hours before this upcoming propulsion opportunity, and then we're just going to press on fairly single-mindedly with that approach.
Thank you very much. You've just heard a press conference with Glenn Lunny and other members of the flight direction team at the Mission Control Center during the major hours of the very serious problems which have developed on Spaceship Aquarius and Odyssey. Odyssey is where the trouble began, the command and service module of Apollo 13, when something caused a rupture to a fuel tank, a liquid oxygen tank on board the spacecraft last night, Houston time, and has caused the mission to be changed very drastically. The spacecraft are both now on a free return trajectory to Earth, meaning that they still must loop around the moon some 7 hours, 57 minutes from now, and then head back toward what is a present flight path toward the Indian Ocean. It's expected that this will be refined later today, and as you have heard in the press conference, there is considerable discussion on several contingencies on how the spacecraft will be brought back to which point on Earth, whether they will try for what's called a super fast return or take just a bit more leisurely route in order to use the consumables, the fuel, the power on board to get these astronauts home safely. The general trend of Lunny's report to us was that they expect to fire the Descent Propulsion System engine at about 2 hours 40 GMT. That'll be at 2 hours 40 GMT Wednesday morning around the world. And which direction that firing sends the spacecraft is yet to be determined. But it looks like they may head for the Pacific Ocean and a return to Earth on Friday. Certainly we expect to be on the air at 9:40 Eastern Standard Time in the United States at 2 hours 40 GMT Wednesday morning to report that for you. I believe we'll be coming on the air at 2 hours 30 GMT. We invite you to stay tuned to Voice of America announcements for further indications of exact timing. We also expect to be on the air at 1 hour GMT tonight, at 1 hour GMT tonight before the spacecraft disappears behind the moon. That's some 7 hours 55 minutes from now. Now, briefly summarizing the press conference and Lunny's report, this happened to be the worst part of a flight to the moon, this particular portion of the trajectory between the Earth and the moon, for this sort of problem to occur, because a maximum service propulsion system engine burn of some 6,000 feet per second would have been required in order to almost immediately turn the spacecraft around and send it toward Earth. The more expedient means has been chosen, and that is to let the docked command and service module swing around the moon and then pick one of several contingency methods of returning to Earth. A descent propulsion system burn last night was performed at 8 hours 43 GMT to assure that the spacecraft would indeed get back to the Earth.
Before that, they were on a hybrid trajectory, which would have caused them to spin off into space after swinging around the moon. The command module apparently is an inert object at the moment. Fred Hayes is sleeping in it. The air is being circulated from the lunar module through the docking tunnel for him there. It is completely powered down. They're saving enough power in the command module itself for re-entry on Friday, and there is a Thursday possibility which may or may not be chosen for re-entry. Hayes will be waked up about now, I believe, and then one of the other men will sleep and Hayes will stand watch. What was the most critical thing during the past events of the last half day? Glenn Lunny says keeping cool, and certainly the astronauts did that. How about water for drinking and cooling? Well, there's plenty of drinking water on board, he said. The only problem would be water for cooling the spacecraft as it's slowly rotating in the sun's heat. The re-entry batteries in the command module are ready. They're all charged up in good shape. They're trying to just conserve power now in the lunar module to stretch out what's needed for the next 3 days. How fatigued are the men? Well, they worked long into the night last night taking care of this problem. And how long will you have to exercise the options available to you? He says up until several hours, within several hours of the planned burn time, which occurs at 2 hours 40 GMT Wednesday morning. So by 0 hours GMT, we probably should know. You just heard a press conference with Glenn Lunny and Harold Loden, LEM officer, Major General Davy Jones, in charge of recovery forces, coming to you from the Manned Spacecraft Center. This is Rhett Turner in Houston.
I'd like to bring them back in sync whenever we can lose 2 minutes worth of data. Okay, stand by, Owen. Okay, control, tell me back to CPs on these data for a couple of minutes. No problem?
Right, no problem.
No problem. The guys flight, no problem?
Guard flight, maintenance flight.
Okay, go ahead.
Recovery, now moving on over to one.
Flight control. Go ahead.
You want to look at the rest of the flight and you can get the copy?
No, go ahead. You can show me the rest of the flight on the TV, too. Okay.
What we have on 58 now is the oxygen. The lower line is very, very faint line. Right there where he's pointing the pencil is essentially our present usage rate. And the dark lines in the upper left are the actual points that we've been plotting.
Okay. Now where does that end up out here? I can't see the right hand there.
Okay, it's a lifetime of 143 and a half hours. Now the trend now is that we're a little better off than 143 and a half.
Okay. How much that's considered? Just the,
that's strictly land. Yeah, land descent and ascent. That does not include personnel. So we do have some.
Okay. Go ahead.
before we had the GPS. Okay, now this does not take into account a second mid-course. It only has one mid-course. It does have the burn in the first mid-course, and it shows at 142 hours we have 590 feet on top.
Are you going to build a profile with the second mid-course here?
Roger, we can do that. That can be very fun.
Okay. Why don't you show that the copy you just made? You can put that second mid-course in there. I can tell the picture a little better. Although that doesn't seem to be a problem.
Okay, we'll do. Okay.
Houston, go ahead.
Two item. As we approach the burn, we want to go through the same check that we did for the last burn. That is, we want to make sure we have everything powered up, circuit breaker by circuit breaker, in conjunction with your direction. Number two, we ought to have a procedure for powering up the command module again when we have to go back into the command module. That's dealing with communication.
Okay, Jim, copy that. First of all, you want to go through the circuit breaker by circuit breaker careful power-up procedure for the next dip's burn, and we're working on that. And secondly, you want a procedure for powering the command module up again when you have to re-enter it and power it up, and we're talking about that and working one out, and we'll have both those for you in plenty of time. Okay, Jack, it sounds as though we probably don't want to power up the command module much before EI minus 2 hours. That doesn't mean we can't start our procedure a good deal before that, but we don't want to power it up much before EI minus 2, over.
Okay. I was just thinking in case something, we had some sort of problem here about how we would go about getting into the command module, what minimum systems we need to power up in order to make it back in there.
Right, Jack. It's quite clear that we're going to have to very carefully make up a full checklist for you on that, and we'll do it.
We're not devoting too much time to that right now, Joe, so we get this burn out of the way in the next couple of days of working here.
Recovery of the land.
Sirius Houston, over.
Go ahead, Houston.
Roger, Jim, we just thought of something, namely that we probably should get the lithium hydroxide canisters out of the command module reasonably soon, just to make certain that they don't stay in there and possibly swell up so that they're hard to get out. I wouldn't wake up Fred for that, but it's something you should do possibly before you go to sleep, over.
Roger, will do.
Okay.
It'll be working into the flight plan by the FAO, and it's fairly straightforward. This is to get the rendezvous out of the way for the AOC. Why don't control flight? We'll just get a copy of it so you can look it over and make sure you're understanding. Control flight.
Go flight.
You got a copy of this procedure for Jackson?
Affirmative. I want to clear with you before I do.
Yeah, it's okay to me, but let's get it in the copy so we can go over it and make sure you understand it.
Okay. Jack, James, look at my block again. It's about dive down or something like that. Give it a command module. And then get us some food and stuff, and then look at that drink procedure. Okay, great. Every hour I've been changing attitude. Based on this. The thing you know about.
the procedure for using the GSM cartridge in the lab?
No, I do print out the checks and do it down there.
Okay, the only point I want to make at this time is that we would like to go ahead and try to use this procedure whenever we use up the cartridges that are presently on. The reason being is to find out whether or not it's going to work.
Yes, I understand that.
I think we're good on this cartridge until at least about 74 hours.
Yeah, I think Dan's almost 75.
Flight? Correct flight.
Just trying to get that. Yeah. We'll take some conversation with Tia until try and stop that. What is the mode function still set to normal?
Yes.
Just get some time and then we'll go back to it.
Yeah. Well, we told him a while ago that this reverses configuration, so he knows what it is.
Yes. flight. Control flight.
Go ahead, flight.
What kind of propellant is taking us to do this 90 yaw?
Standby flight.
Pretty small, isn't it? Info flight.
Go ahead, flight.
What's coming up in about another 15 or 20 minutes and another 90-degree yaw. Are we going to get anything changed on it?
Negative. We'll have to go to the gas. Flight control.
Go ahead.
Yeah, that definitely is. It's taking about 4 times as much in this PCC mode as it did yesterday before we started this.
Okay, I guess.
As far as, in other words, we cannot, when he sets up the 90-degree yaw, we really can't tell the difference. That, okay, it's taking that much for the yaw.
The assholes are actually passing.
Yeah, we can see the mouth holes faulting right now. I mean, we can tell that there's jet activity in quite a bit of it.
Control flight. Control flight.
Go ahead, flight.
What kind of use rate do you have?
I think it's about, let's see, I got the increase. It was 2.6% of standby flight. Flight, we're using about 1% per hour now. And yesterday we were using 0.2% per hour. The increase is within, I guess, the last hour or so has become very evident to us. But we don't, I mean, there's no other.
Is that band still the same?
That's as far as we know, the last step dead down 5 degrees and we're still there.
I got leaks in the air.
Say again?
What kind of leaks in the air?
I think the only other thing we can do is go free. I don't think so. Stand by. I need to confirm that. Okay, it can be done through the e-memory. We don't know whether we recommend it yet. We're checking on it with Stan, and we'll get back to you momentarily.
Yeah, let's see if we surely, we can get the thing opened up for everything plus minus 15, 20 degrees. The limit factor there is a whole lot lower. God, damn. Well, how to stick that in there?
Right. We're working on it, Mike.
Okay. Who's calling you, Joe?
Aquarius, Houston to Joe. Not very good, Jack. Suggested that for communication here we go to power amplifier, circuit breaker in, and function switch to voice.
Okay, I didn't want to get through anything. I just wanted to check and see if we hedge at all in this mode.
Yes, we do have comm. You're extremely noisy, but if you read loud and slow, we can usually copy you.
Okay, Joe, I read you loud and clear on that mode.
Raj, we understand that. It's strictly a downlink problem, and you can stay in the down voice backup mode if you want. If we get involved in conversations, I think we'll want to go back to normal voice.
Flight network.
and understand you'd like to know the GET of your initial power-up. Is that correct?
Yeah, the second time in here.
Okay, stand by.
What was the question?
Yeah, we couldn't get him that much time. Tell me, AFB. Go ahead, AFB. Did I copy that they want an approximation of when they originally went to internal power on the left? No, they want an estimate on when we're going to power up the limb for the dip burn on CECS. Do you have a feel for that? Okay, I'm assuming T3 plus 2, I guess. Roger, you mean 2 hours before. Say again? You mean 2 hours before the burn? What would you like to say? Well, assuming it burns at T3 plus 2. FAO flight. Okay.
Aquarius, Houston, over.
Go ahead.
Okay, we don't have a precise time of starting into that procedure for you yet. We're working on it real hard. It won't be for several hours, and we'll pass it up to you just as soon as we get it, over.
Okay, and Joe, do you want us to start our PTV maneuver at this time?
Stand by and I'll check.
White Capcom, are we ready for another yaw maneuver?
Okay, we're ready for another CP3 minute, right? Control flight.
Go flight. About 6 minutes flight.
Okay, info, we're going to have to switch on these when? Sometime during that maneuver?
Yeah, sometime after we start the maneuver.
So can we do it as soon as we start the maneuver, or should we just wait to get called?
Probably wait like it's probably better.
We'll just wait till
Aquarius,
you're
Houston.
Go ahead.
Roger, Jim, we'd like the next yaw maneuver in about 6 minutes, over.
Roger, 6 minutes.
Okay. Houston, over.
Go ahead.
Okay, our estimate is that we will start powering up for the dips burn at about 76 hours elapsed, which is about 6 3/4 hours from now.
Okay, Joe, about 76 hours or so, and I guess you misunderstood. My question was, what was the DEP way back when I first came across to the limb and transferred to limb power? How long have we been living on the limb now?
Oh, Roger. Standby, I'll get you that.
Tell me,
Yeah, I did misunderstand.
Go, Mike.
Can you give back in the records and find out what time we powered up the lamp, what time we transferred the lamp power?
Roger. What, Tony? Right, go ahead. Okay, they switched to internal power at about 57 hours, 11 minutes. That doesn't agree with the number we have in our log. Okay, well, that's not for the TV pass and the key pressure checkout. This is when they fly again the study. Okay, say that number again. 57, 11. Are you interested in the other number as well? Well, why don't we get it in case he wants to know. 57 plus 11 is the last S13 seasonal limb. Right, and the initial entry was at 54, 46, 15. Right, okay. You copy this, Jim? That sounds not right.
what pressure limit are you looking at on that A13? What pressure limit? Yeah, I think you relieved that once earlier. That's affirmative, and we're going to do it again pretty quick, probably when the pressure reaches about 950. Okay. Tell me if I... That's right. Does that kind of a procedure to do that? To do what? To relieve that accent thing? I don't think we have a written procedure. It's a two-step thing that we've voiced to them before. It's not complicated that. Okay. Close the D10 O2, supply and open access. That's right. We'll come see you when we're going to do it. Right. So you go to aft Omni, please. Roger. Capcom, would you go aft Omni, please? We'd like to aft Omni. Aft Omni.
Aquarius, Houston, over.
Go ahead, Houston.
Roger, we request aft on me at this time, over.
Aft on me.
That's fine.
We're looking good, flight. Again, we're looking good.
This is Apollo Control. It's 70 hours, 12 minutes. Apollo 13 now 203,670 nautical miles from Earth. Velocity 2,910 feet per second. We'll continue to stay up live for any air-ground transmissions.
flight controller, give me a amber light. Okay. Recon, you with me? Recon flight.
Flight recon.
Okay, just send that picture. You know, pretty what we can try to do. FAO, you up? Okay, guidance?
Go ahead, flight.
Okay, let me summarize now what we, no big changes here, but I want to go over some things that we just discussed and agreed to do. Okay, we're going to go with the PC plus 2, a maneuver that approximately 900 feet a second. Will get us back to a landing in the Mississippi at 142 hours. Now, the big thing that we got to do now, and FAO and guidance, I think is primarily interested in this. Do we want to do a test with the sun in the AOC to give a handle on how our alignment is right now. Now, we don't have to do this procedure right now. In fact, we're running a rate of guy, and we're supposed to be time we're going to power up. We ought to be looking at the attitudes that we're going through in the CC2 and pick the one that's closest to that to do this test. And we want to do a swing test, test the alignment of the wind factor as it is right now. Okay? If that's within, if that alignment looks good, indicating that we've got a good alignment sometime back and the test is not been bad, then we're going to go with the platform as it is right now. That one is set to 252. Okay, if we're outside of what we call a good alignment, and right now we're defining that as about plus or minus 1 degree, then we'll want to do an Earth, Sun, option alignment prior to going into darkness. Okay? We will then set them up in an attitude and pick a good bright star for it, so when they go into the darkness, to get them to check if the AOC with the Earth-Sun alignment is indeed good, much more better than the order of supplements can do. I think the only problem we've got to go through here constantly with the crew is going through this Earth-Sun thing, which is something they may or may not be aware of. They have quite thinking about it. Going through the procedure and how to do it. Stand by here. See if somebody else is there. What else is that? What about it? Now? Maybe?
Fine, sir.
Well,
in order to make this swing test accurate so we can really tell what's going on, we need to point the sun at AOC right at the sun. If it's out near the periphery, it's not at 3 for degrees.
Right. So you need it back in the center. Okay, so you can select the attitude too.
She'll work.
Well, you got a question. What's that for that?
What's the training
I think we had a 15 minutes here. Just
flight income. Well, while everybody's looking at this, I assume you're going to bring the power in to do this, to talk to them?
When they do cross over, yeah.
Okay, what we'd like to do is to go to normal voice at that time and go to ranging and get some PRN data for FIDO while we're doing it. It might cost us a dB and a half, but I think we're going to be in good shape. No, well, you're going to have to bring the power amp in, okay?
This is Apollo Control at 70 hours, 24 minutes. A decision has been made to perform the Paracynthian plus 2-hour maneuver. This will be a docked descent propulsion system burn.
Go ahead, Fly.
Okay, Ken,
of
for this
approximately
thing,
900
Charlie
feet a second.
working right with the FAO. You'll probably want to
And
stay up with it because
we'll bring landing in the Pacific Ocean at 142 hours elapsed time.
I'll be working with him.
We'll be passing up to the crew a procedure shortly for them to perform a sun check in the alignment optical telescope of the lunar module so that we may better understand what the present LEM inertial platform alignment is. If as a result of this sun check the platform looks good, we will perform the maneuver without a platform realignment. If it does not look good, and the limits on this have been defined as plus or minus 1 degree, we will do what is termed an Earth-Sun option alignment before going into the dark behind the moon and set up the attitude of the spacecraft so that the crew can mark on a good star while they're in the dark to check the Earth-Sun alignment that they will have performed previously. Apollo 13 now is 203,957 nautical miles from Earth. Velocity is 2,894 feet per second. Jim Lovell, the spacecraft commander, and Jack Swigert, the command module pilot, have just started a 6-hour rest period. Lunar module pilot Fred Hayes is awake at the present time. We will be passing information on this decision up to the crew very shortly. This is Mission Control, Houston.
We've got a photograph of the cancer coming in from Utah to clear up a couple of weeks ago. Which end of it was stashing back here and we'll block it up. But aside from that, it looks feasible. The only thing that's going to do it, I can think of, is it's going to slow down or block the flow we have going to the command module. Yes, sir, but I'm thinking maybe we had enough to try it prior to the CC.
And Flight in work is proven that we can latch up two sweep circuits together so we can use LEM fans and stuff like hydroxide. The preliminary indication that doesn't make it do it. So we might have that answer before we have to execute this one.
last time this year spring, you can be thinking in these terms. When we're talking about this sunset, and now which will leave us enough time if it's no go to try the Earth-Sun align option, and then get into altitude for Earth-Sun cycle. That's it. Retro flight. Go flight. Where's our 153 free return? Where is it?
It's off of Madagascar. Let me see. It's going channel, let's see, 76, I think. No, hold on.
This is Apollo Control at 70 hours 32 minutes.
Did you want to know more exact than that?
The elapsed time of this planned
I don't think so.
lunar module engine
that's close.
maneuver is approximately 79 hours 25 minutes.
Wait a minute, stand by on that. That's
We expect to do the sun check at about 74 hours elapsed
Right, it's
time.
around 58 degrees east and 20
We're now 6 hours 36 minutes away from
What was the south?
loss of signal when the spacecraft will go behind the moon. We'll stand by for any air ground now.
Let me get the data for you. Right, look like 76. About 2135 south, about 60. I'm sorry.
That's
20 degrees, 30 minutes south, and 60 degrees, 10 minutes east. You can see that's Madagascar there on the left.
okay.
All right. Korea, Port Retro.
flight so far. Fred is down here. So I think we know enough about the plan here that we ought to start the launch and what we're thinking about that is. We're going to get there with the engine time with the left station. At about 74 hours, and we're giving the adjustment, it probably will be exactly 74 hours. We'll do this sun check. The procedure for doing all this being worked out now. It's not exactly straightforward because every time it's exactly what it is in the computer and guidance equipment and 88 flights, fabulous delays, different airplane sectors. So the first as well as ready for safety. Now, we're going to do the sun check at 77. With that, we're going to recognize the energy. And we're going to go with the alignment that we've got manufactured. If that is no go, then we're going to do an earth sun alignment. And we'll go through that with it a little later. So we're going to clean up the procedure and make sure that all is necessary. And then as soon as we get that aligned and we're getting to working power gauge, it's going to start the section goes into darkness in the burn energy. Power gauge is going to be kind of starting to do some we'll probably open that up even higher. We'll be checking the 5 gauge. That's when we start to set up the that's doing it right now. Okay, we'll give him a pass for the burn prior to LOS. And while he's on the back side, if we soon go around with this will be some monitoring. We'll update our suggestion. We'll update the path and point around for the burn if it's successful. Doing the preliminary test for this updating and things like that. That's about all we've done.
pass this rough plan up to the crew and up to Fred, and I want to know whether Info wants him to power up the power amplifier and the ranging switch.
I kind of think we should at least get the power amplifier in normal voice so that we can hear it well. You know, if we want to ask a question.
Okay, I'll do
Now,
that.
what about the ranging?
Okay, if we can get some PRM for Fido, it really would help him. Okay?
Fido flight?
Fido flight.
Would you like some ranging?
Yeah, man.
Okay, we're gonna bring up the power amplifier to make sure we got a good time with the crew to kind of go over this plan. So, the answer to your question, Capcom, is yes. We'll have to pick up the ranging. Yeah.
Okay, range function switch to range. Amen.
Okay, power amp, circuit breaker.
Circuit breaker closed and the voice switch to voice.
Voice switch to voice.
No biomed, no low, and stay in low bit rate.
Fred, I have a few words for you on some things we want to do in the next few hours. And in order to get good comm for that, and also in order to give Fido a few minutes of ranging, I want to have you put the power amplifier circuit breaker on panel 16 in, the voice function switch to voice, and the ranging function switch to ranging. Over.
Now I'm in normal voice, and ranging is up.
Okay, Fred, and you're loud and clear down here now. Okay, what we're getting a procedure ready for you is to do an AOT sun check at approximately 74 hours, or in just a little over 3 hours. That'll be in D10-2. We'll have a detailed procedure up shortly, and it will include the rendezvous radar redesignation to get it out of the way and a P-52 maneuver to the attitude. It's our feeling that if that checks out within 1 degree, that your platform will be okay for the burn without a subsequent P-52. If it's not within 1 degree, we are working up an Earth-Sun alignment procedure to align the platform, and we'll have that up to you later. Okay, assuming that the sun check is okay, we will then give you a star for a confidence check on the backside when you're in the darkness. We'll be updating a burn pad to you prior to LOS going around the moon. We'll have another look at you after AOS, and we'll update the pad if required. Right now, that update should be very small. Over.
Thank you. Also, good seeing you, Theo. We're going to give him about 900 feet a second, 142-hour landing.
Say again, point.
I think you ought to just tell him that, confirm that we're going to give it, it'll be about a 900 foot per second burn at PC plus 2, and we'll land at the mid-Pacific line in 142 hours.
Roger
if we do that.
Flight from control.
Go.
At your convenience, I'd like to brief you on the RCS, what we found out so far.
Okay, can it wait till after
Yes, sir.
Sure can. Okay.
Bye.
Okay, Joe, as I read that, at 74 hours, we're going to do an AOT sun check at descent 2, which is going to require the rendezvous radar out of the way, and we'll use P-52 auto maneuver to get there, or at least the angles out of that. And if this passes within 1 degree, you're saying the platform is okay for the maneuver, and we won't need a subsequent P-52. But even if it is okay, you'll give us a star, which we can use for a check when we're in darkness. If this check plumps, you'll pass us on up then an Earth-Moon alliance procedure.
And we'll still give him a star after that, too.
Okay, Fred, that's correct, except that the align procedure that we're working on is an Earth-Sun align. And other than that, that's correct. Incidentally, this PC plus 2 maneuver looks like it'll still be around a 900 foot per second maneuver, and that it'll get you back to the mid-Pacific line at 142 hours.
Okay, that was an Earth-Sun check. Yeah, we're getting a little close to the moon now. And the PC plus 2 maneuver still looks about 900 foot per second to get us in mid-pack at about 142 hours.
That's right.
Flight, how long do we want to stay in this calm mode?
Let's hold it here for a second. Fido flight. Fido flight.
We're getting it flight, but
I just want to know about how much of this you're going to have to be useful, because we don't want to use any more power than we have.
Understand, flight. It's coming in. We're not sure that it's valid. We're going to have him reapply one more time, see if it doesn't help.
Have he who?
Madrid.
Okay.
Re-range, Johnny. Flight Captain.
Go ahead.
Roger, Fido tells me he's got enough ranging, and with Inco's concurrence, I'll go back to down voice backup.
Down voice backup, ranging to off, and power amp, circuit breaker open.
Okay. Thank you, Flight.
Okay, and we'll be talking to him in a little while.
Aquarius, Houston.
Go ahead, Joe.
Okay, Fred, we've got a good batch of ranging, and now we'd like you to reverse the configuration. Ranging to off, voice function to down voice backup, power amplifier circuit breaker out. We'll be talking to you.
Down voice backup with the power amp breaker open now. How do you read?
We read you satisfactorily, Fred.
Okay. Jim and Jack are in the upstairs bedroom taking a nap now.
I didn't know that was upstairs.
We're now at the first space station.
Tell me, Flight.
Go ahead, Flight.
Okay, two things I want to submit to you. One, I understand that the next canister change is scheduled around $75. We need to get on this other procedure for doing the scrubbing with those alternate procedures. I would like to do that after the burn if we can. It's a fairly involved thing. We need all three crewmen up, and we're going to have a handful once we get these guys up, getting these alarms and stuff out. So I prefer to do that after.
That's right. We changed our procedure a little bit, and we also will wait till after burn.
The other thing is that you and Span also should be thinking about, once we do the PCC thing and power down, we should, there's some trade-offs about it. We probably should use up at least some of the other oxygen supplies rather than the ship supply. I'm talking about switches now. Although you're going to start looking at the entry situation too, to save an ox, maybe and take it over to the command module with you, or not. But those type of things we ought to start getting people thinking about. That is, turning off the land ship supply and using up some of the backpack stuff, and determine what we want to save to take over to the command module with us.
Right, the backroom's already looking at that. And on the canisters, what we would like to do now is use this canister, then switch to secondary, and go ahead and use that one. Meanwhile, they're running testing on the CSM canister configuration. And by the time we get through the secondary LEM canister, we should have some good word about how to use the CSM system.
Okay, we'll wait for your call on this, and we won't try to schedule any flight time. When you're ready to switch to secondary, just
Roger. Over. Flight control.
Control, can you hold one?
Houston, Aquarius.
Aquarius, Houston, go ahead.
One other thing you might have somebody look at, I don't want to bother the guys upstairs. The drain hose that we got in the command module, I wonder if somebody can find out if it will plug into the pressure, and in which case we can keep transferring
Fred, let me verify that.
Okay, control, flight. Control, flight.
Go flight.
Okay, we're ready to maneuver?
Yes, sir, it is. It has not started
Is
yet.
that what you were talking about?
Yes.
Okay, control, flight. Are we going to have an Omni switch?
Negative flight.
Okay, Captain Omni, go.
Fred, Houston, that's verified. You can go ahead with the yaw maneuver.
Roger.
Taxi flight.
First flight.
Ken, I just want to make how you doing.
I'm working with FAO. We're getting these units up to the way that we want to use it.
Everything's falling into place okay?
Yeah, I think so. It's just a matter of checking out all of it.
Okay.
Flight retro.
Go ahead.
Recovery requested return to EOG back to the 142 when they landed, and I said it was okay.
Okay, concur.
Right.
your flight.
Go ahead, Mike.
Do you have a latest oxygen remaining that I could put on this tray like that up here? The card you gave me.
Right, I'll give you a point in a minute.
this is Houston.
20 degrees, roll left. Yeah. Go ahead.
Okay, Fred, I didn't copy the beginning of your message.
Okay, I was just talking to Jim here.
Sorry.
Go, fighter. That ranging knocked our uncertainty and position down from 40,000 feet to 100 feet. We verify 135 miles. Oh, we're good.
guidance flight. Just a status check. How you doing?
We're doing okay. I'm getting with FAO now. We're going to write up the stuff we want voiced up.
Okay.
Flight retro.
Go ahead.
Just to keep you on board, we're about 4 feet per second of being pre-return at this time, and that's doing a burn like, 90 hours. So we achieved our goal. We got well within RCS capability of pre-return with that first burn.
Okay.
Of course, we'll be updating this, but that's, what we got on this last tracking data.
Okay. flight.
Go flight.
Has Capcom got a copy of this yet?
I'm going to take one down to him right now.
Okay, and make sure guys got a copy of the flight plan update.
Roger.
Control flight.
Go flight.
Okay, does the procedure you gave to me some time ago on redesignating the radar get it out of the way for defense to say this?
Does it get it all the way to defense 2?
Out of the way.
Out of the way, yes.
Okay, that procedure you gave me is still good.
Yeah, there were a couple of additional circuit breakers that had to be closed up at the top. I think Charlie got them. Stand by.
flight.
Flight stand, go ahead.
Hey, do you have a phone number down in room 210? Can you talk to somebody down there?
Yeah, we'll see if we can get you one.
Listen, all I want to do is, I'm Charlie Breacher's down there, and I'd like to get him up here to make it.
Okay.
Russell. Guidance. Just started.